students, this is your friend Sumit, and today we are going to start topic 5 of our series, that is laws of motion. Laws of motion is the king of mechanics, and this is, I'll say, one of the most important chapter which builds the fundamentals. Actually, the weightage of this chapter is not that great in mains. In mains we can expect almost one question from this particular chapter, but the thing is the application part of this chapter is there. In all the chapters, I'll say whole throughout, you'll see the application of laws of motion. Okay, so many of the topics of this particular chapter are very confusing for the students, like pulley problems, the friction, when the friction is kinetic, when the friction is static, okay, the circular motion problems, and other types of things. So all those concepts will be discussing in great detail. So make sure you watch this video fully and comment on the video that you watched it fully. With that, we have a very good set of collection for questions for you to practice, and that is available in the description box. So the notes as well as the practice sheet is available in our app. So the link for that is in the description box. When you click that link, you'll join the free batch on our app. And as you know, the PW app is one of the most trusted platform where you get quality teaching at affordable prices. So join the batch there and access the content. Let us begin the discussion. Topics. So we'll be covering all the details of this chapter. Laws of motion, its application, the next is the friction, the circular motion, all these things we'll be covering. Now, first of all, let us discuss Newton's laws of motion. The first law, law of inertia. We know there are three types of inertia. There is inertia of rest, there is inertia of motion, and there is inertia of direction. Okay, a body is at rest. Okay, if you, let us take, suddenly try make it move in some direction, so what will happen? So let us take, you are sitting on a bike and all of a sudden the escalator is placed and the bike starts moving. So what happens? You fall at the back. Why so? There is inertia of rest. Next is inertia of motion. You are sitting in a bus, there is a brake. You are moving, now there is a brake. Okay, so you fell in the front. So what happens? There is an inertia of motion there. Okay, you are coming from motion to rest. Therefore, there is some inertia. Next is the inertia of direction. If there is a change in direction, there is also inertia. So the fundamental thing. Next is the second law of motion. So second law of motion states that the force in a particular direction is equal to the rate of change of momentum in that direction. So if I say force F in a particular direction, maybe along x-axis or maybe along y-axis or any direction. So F, we will say that is dp by dt. Like this. What is P? P here is our momentum. P is our momentum, that is mass into the velocity. Okay, so if I write it here, F is equals to d by dt of mv, and if my m is constant, I can take m out. Okay, generally the mass remains constant. If the mass is constant, we can take this out, and then this becomes m into dv by dt, that is a. Okay, so this is our second law of motion. Now when I'm writing, let us take this equation, F is equals to ma. There is some acceleration along x-axis, there is some acceleration along y-axis, let us take there is some acceleration along z-axis. Then what I can say, I can separately write, like I can say that force along x-axis is equals to mass into the acceleration along x-axis. Force along y-axis is equals to mass into acceleration along y-axis, and I can say force along z-axis is equals to mass into acceleration along z-axis separately, because direction in these three directions here we are saying these are independent. Okay, x, y, z, perpendicular to each other. So when we say force along x-axis, that will be just mass into the acceleration along that axis. Now momentum. So momentum is the product of mass and the velocity. So let us take a body is moving with velocity v. So we write the momentum p as m into v. And here also I can say the momentum along x-axis will become mass into velocity along x-axis. Similarly along y-axis. Similarly along z-axis I can say. Okay. Now impulse is equal to change in momentum. What is basically, this is our impulse momentum theorem. Okay, so what is basically impulse is? Impulse is, let us take a force is acting for dt time. So this integration of f dt, this is our impulse, and this we denote with I. So what is integration of f dot dt? Now I wrote that f is equals to dp by dt. This we wrote. Now from here if I write dp, this is f dt. Now I integrate it like this. Time goes from, let us take 0 to t, and momentum goes from some initial momentum p initial to p final. Okay. And what it is now? So we'll say this p final minus p initial is equals to this integration of f dt. So what is this? This is change in momentum delta p, and this is my impulse. So this is impulse momentum theorem. So the impulse on a body is equal to change in momentum. Now if I say impulse along x-axis is equals to change in momentum along x-axis, impulse along y-axis is equals to change in momentum along y-axis, impulse along z-axis is equals to change in momentum along z-axis. And you might have seen questions like, let me show you. You might have seen questions like, let us take, this is 4, this is 6, okay, this is my force, this is my time, this is 10. And in this question it may be given a particle was moving with velocity, initial velocity, let us take 2 meter per second, and then this okay force was acting. This force was acted from 0 to 6 seconds. What will be the velocity at t is equals to 6 seconds? Okay, so here let us take initial velocity is given to you, that is 2 meter per second, and the mass is given to you as 1 kg. Now what you need to tell, what is the velocity at t is equals to 6? Now here what we will find, what is the total impulse due to this force? What is that? That is area under ft curve. So how much is that here? How much is this? This total area. So this is one square, this is one triangle, and this will become 40. And what is this? This is 1 by 2 into base, that is 2, into the height, that is 10. So this is 10. So total area is 50. So impulse becomes my 50. And now I'll say this 50 is equals, let us take initial velocity was along positive x-axis only, okay, positive direction. So I'll here say this is mass, that is 1 kg, into final velocity minus initial velocity, because p final minus p initial, I am taking here mass outside, okay, so here inside it will become v final minus v initial. So here I'll write this as v, and minus initial was 2, like this. From here I got v as 52 meter per second. Getting it? ft curve is given, I got the area of this ft curve, that is my impulse, and that impulse is equal to change in momentum. And whatever is the initial velocity, other things are given, we can use to find the final velocity. Now coming to question before that, one more thing. Here we wrote that f is equals to dp by dt. Okay, so at any instant the rate of change of momentum we know, that is equal to my force. But can I convert this into average form also? Yes. So I can write from here, this f is equals to dp by dt. This I can say that f average is equals to delta p by delta t. Okay. The same way we used to define the average velocity, that is the change in the position divided by the time interval. Okay, instantaneous velocity was rate of change of position. Similarly here f average is, instead of dp we will use delta p, instead of dt we will use delta t, and this will become my average velocity, average force. Now coming to this question. Okay, so this question was asked in JEE Mains 2024. What he's saying, a cricket player catches a ball of mass 120 gram moving with speed, that is 25 meter per second. If the catching process is completed in 0.1 second, then the magnitude of force exerted by the ball on the hand of the player will be. So I need to find magnitude of force. Okay, here duration is given to be 0.1 second. Okay, so what I'll use? Average force method. So what is average force? I'll say average force is equals to delta P by delta T. Here he is saying the exerted by the ball on the hand. The force ball is applying on the hand is same as the force hand is applying on the ball. We understand that. Okay, so for any of that, because I just need the magnitude. So what is the change in momentum for the ball? What is the change in momentum for the ball? I just need magnitude of this. So what is, I'll say this is mass into change in the velocity divided by delta T. What is mass here? Mass is 120 grams. So I need to convert that to kg. So 120 divided by 1000. This is in kg now. Now velocity, what is the velocity? 25 meter per second. When it is stopped, it will become 0. So change will become 25 minus 0, that is 25. So into 25 divided by, what is the duration? Duration is 0.1, 0.1. So here this will get cancelled. This will get cancelled. 5 into 5, 5 into 2, 2 into 6. Is it right? Yeah. This is 30. F average is 30 Newton. Okay, we know the unit of the force, that is Newton. So here it is mentioned SI unit, so it's the same thing. Another question, a gun of mass 10 kg fires 20 gram bullets at rate of this, okay, with a speed of 100 meter per second each. Now here the recoil velocity of the gun is. Now here you need to understand. Here we are saying that F is equals to dp by dt. If let us take, we have a system where F is 0, okay, here where F is 0, so what you will say, if F is 0, then delta P is constant, dp P is constant, it means P is constant, okay, because the differentiation of constant is 0. So if I say F is equals to 0, let me write with a different color here, yeah. So if F is 0, so 0 is equals to dp by dt. What does it mean? P is my constant because differentiation of constant is 0. Okay, so here comes the important statement, and what is that? That if the external force is 0, then the momentum is conserved, and this we say conservation of momentum. Now external force, if on one body I'm talking about, so I can say on one body, if external force is 0, the momentum of one body will be conserved. And if let us take, there is system of bodies, there are 2 or 3 like that, so I can apply on that also. If there is the external force on this system is 0, the momentum of that system will be conserved. Okay, so I can say if external force on a system is 0, its momentum is conserved. Okay, so this is the thing, this is the condition. Now when we apply conservation of momentum, we should see that whether the external force is 0 in that particular direction, in which direction we are conserving the momentum. Okay, if we are conserving momentum along x-axis, we need to see whether the external force along x-axis on that system is 0 or not. If it is 0, we can apply. If not 0, we cannot apply. It may happen the external force is there along y-axis, but it's not there along x-axis, so we can conserve along x-axis. Okay. So gun of mass 10 kg fires 20 gram bullet at rate of 180 bullets per minute with a speed of 100 meter per second each. The recoil velocity of the gun after 1 second is, so in 1 second I'll say it starts firing. So in 1 second it would have fired some bullets. It would have fired some bullets. So I'll say that the system, here the system is my gun plus the bullet. Okay, that is my system. So is there any external force on the system? No. So the gun plus bullet is my system. So whatever initially if I talk about, the bullets are not fired. What is the momentum of the system? 0. Now when the bullets are fired, bullets are having momentum towards the, let us take in this direction, towards the positive x-axis. Okay, so the gun should have momentum towards the negative x-axis, then only the total momentum will become 0. Now I am saying that after 1 second, it has initially I am saying that what was the condition? The gun is there, the bullet is there, both are at rest. So velocity of gun is also 0, velocity of bullets is also 0, and both are rest. So I'll say the initial momentum is my 0. Now after 1 second, the bullets, how many bullets in 1 second they are fired? So 180 bullets per minute. So if I talk in 1 second, 180 by 60, that is 3. Okay, so 3 bullets are fired. So what is the momentum towards, let us take towards the right, the bullets are fired. So what is the velocity of bullet? 100 meter per second. Okay, so what is the momentum of the bullet towards the right? Okay, so momentum of bullets. What is the mass? Mass is 20 gram. Okay, this is 20 gram bullets. Mass of the bullet is 20 gram. Okay, and how many bullets are there? There are 3 bullets. Into what is the velocity? That is 100. Okay, this is the momentum of the bullets towards the right. I need to convert gram to kg, so dividing with 1000. So this is 6. Okay, now the momentum of the, I'll say momentum of the gun should be towards the left. Okay, so what should be the momentum of gun? That should be -6. -6 means towards the left. I'm taking the direction here. Okay, why towards the left? Because P initial is 0 and P final has to be 0 because there is no external force. So I'll say 6 is equal to, just writing the magnitude, the velocity will come towards the left. 6 is equals to mass of the gun into its velocity of the gun. So velocity of the gun comes out to be 0.6 meter per second. That is option D. Getting it? So whatever is the, I'll say, momentum of the bullets towards the right, that momentum has to be of the gun towards the left, then only the two momentums will become 0. Initial momentum was 0, final momentum is also 0 because there is no external force on the system of gun and the bullets. Now you may say, sir, somebody might be holding also, because but that is not mentioned. We will not consider that like some external force is there or not in this case. Okay, at any instant, the velocity of the particle of mass 500 grams is this. If the force acting on the particle at t is equals to 1 second is this, then the value of x will be. This is the velocity. We know force is equals to mass into acceleration. Velocity is given, so I can write acceleration as rate of change of velocity. Simple. Okay. So what is mass? Let us put mass is 500 grams, convert that to kg. So 500 by 1000, so it will become 1 by 2 kg d by dt of, now this is 2t I cap plus 3t square j cap. So you can differentiate separately the I cap thing and j cap thing. This will become 1 by 2. Differentiating 2t, 2 is constant, we'll take out differentiation of t is 1, so 2 I cap plus differentiating 3t square, 3 is constant, taking that out, t square differentiation will become 2t, so 3 into 2t, 60 j cap. Here it is saying t is equals to 1. Now put t is equals to 1. So this will become 1 by 2 into 2 I cap plus 6 j cap. So this is 3 I'll say I cap plus 3 j cap. I cap plus 3 j cap. So this is I cap plus x j cap. So I'll say my x is equals to 3. That is option A. It will not take so much time for you to solve in the exam. Velocity is given, differentiate, put t is equals to 1, get the force. I'm showing you the steps. Therefore, it takes some time to solve. Now, the third law, that is one of the, I'll say, most famous. So here, what we say generally is that it's the law of action reaction. If A is applying some force on B, B will apply some, I'll say, some equal and opposite force on A. That is the meaning of this. Okay, let us take, this is a box. Okay, and here a person is standing and trying to push this block towards the right, applying some force F on the block. Now what will happen? Same force block will apply on the person. So person will also have a equal and opposite force, and that is Newton's third law. Okay, just another example. A block is kept on the ground. Okay, now block have force due to gravity. Okay, and I'll say it is placed here. It will have some force on the normal force on the ground. Okay, that we say it is applying some force, normal force on the ground. Now this ground will be applying equal and opposite force on the block. Okay, another example is, let us take two blocks are there, A and B. You are applying some force from this direction. Now here there will be some force between A and B. Let us take A is applying some force, that is N. This normal force A is applying on B in this direction, on B. So B will be applying same force on A. When you talk about A, it will have a force N in this direction. Certainly external force will also be there on this, but this is the force from B that he is getting. Okay, this is our Newton's third law. Now some classification of the forces. One type of forces is the field forces, where contact is not required. Okay, let us take this span is there. If I leave it, it will move in the downward direction. Why? So there is force due to gravity. Okay, how the force due to gravity is acting? Is there any contact with the span? No contact is there. So that force is field force. The gravitational field is there, and that gravitational field is pulling it down. Okay, so I'll say that is a field force. Another type of force is contact force. Contact force is I am pushing it. Okay, therefore I'm maintaining a contact and then I'm applying a force. Or there is a rope. You may say this is a block. Okay, and it is connected with a rope, and you are pulling this rope. There is a contact, isn't it? Or you are standing here, you are applying force on this. So all these type of forces are contact forces. Two surfaces are a contact, there is a contact force. Now type of the contact force is tension force. Two blocks are there, we are applying this. Rope is there in between. Okay, some tension force will be there. Now the nature of this force on a rope, force due to rope, if I say, is rope can only pull. Can rope push? No, rope can only pull. So when we are pulling it, this block 1 kg towards the right, so what is happening? There will be a tension in the string, tension force in this, and that tension force, if this is connected with this 1 kg, it will be pulling it back. So for 1 kg, if I say this block 1, not 1 kg, for block 1, if I say this, my tension force is acting like this. I'll show it like this. For 2 kg, if I say, it will be pulling it in this direction. So when I talk about this block 2, not 2 kg, block 2, the tension force is acting like this. Generally, when we talk about tension force in a rope, we consider the rope or my thread or the string to be ideal. Ideal means massless, inextensible. The length cannot change and the mass of this is negligible. Okay. So what happens due to this? The tension will remain same whole throughout. So whatever is the tension here, the same tension will be here, the same tension will be here throughout the rope. Okay. So we consider the string to be massless and inextensible. Inextensible means the length will not change, and this we call as my ideal string. Okay. So in case of ideal string, the tension will remain same throughout. Whatever is the tension here, the same tension will be here. Whatever is the tension here at this point, okay, there is some mass in this case we are considering. Okay. So sometimes what happens, there is a rope and we have given some mass of the rope, like in this case. Now the tension will not remain same throughout, the tension will change. Getting that point also? Okay, here one more thing, we are saying that this tension is same both sides, so we are considering this pulley to be frictionless. And massless. This pulley also to be ideal. We'll come to that when we will be discussing about the pulleys. Okay, pulley also we consider to be ideal, to be frictionless. Ideal pulley means the pulley is frictionless and the pulley is massless. Okay, now in this particular case, if I talk about, there at this point there is some force, or I'll say let us take this tension is T1. At point C, if I talk about, because there the mass of the rope is also there, here the tension will change. Here it will not be T1, here it will be T2, somewhat different. Getting it? Generally, when we talk about, we consider the strings to be massless, the tension is same whole throughout. Now, let us talk about the spring forces. Now, spring also, we assume the spring to be ideal. Ideal means the spring is massless, and in that generally, like when we talk about ideal spring, this, let us take this natural length is L of the spring, and we say the spring constant to be K. This is my spring constant. Or the force constant of the spring. Same thing. If that is K, the elongation or the compression is X, the spring force is my Kx. Okay, where X is the elongation or compression. It follows Hooke's law. Okay, so the force, whatever the, let us take, we are pulling it, we stress till X. Okay, so how much force this spring will apply back, because the spring will want to get compressed back, so how much it will apply back, Kx. And now if you have pushed it, compressed by distance x, the spring will apply a force back because it will try to come to the natural length. Okay, it will apply force in this direction. How much that? That will also be Kx. Whether x is compression or x is elongation, the force is Kx, but here the direction changes. You understand? If you pulling a spring, spring will try to go to the natural length, it will pull you back. Okay, if you pushing the spring will come to the natural length, it will push you back. Okay, one more thing about the spring, that the spring constant is inversely proportional to the length of the spring. This is I'll say a important thing about the springs, that this spring constant or the force constant K is basically inversely proportional to length. Okay, this is length of the spring. Length means the natural length, not extension or compression, natural length. While extending or compressing, consider the spring constant remain the same. But let us take a spring is there, whose spring constant is K, length is L. You cut this half. What happens? The length becomes half. So what should happen with the spring constant? If length is half, means spring constant will become 2K, twice. Okay. So if I'm saying that this is my spring constant is K, length is L. Now I cut it into two half. I am having two smaller springs, length L by 2. So my spring constant will become 2K, like that. So this you should understand. Sometimes a question is given, a spring was there, it is cut into two halves, and then you can say some object is connected to one of the half, and how much the extension will come if this much force is applied. All these type of things can come. So you need to understand simple thing, spring constant is inversely proportional to the natural length of the spring. Okay, so this question was asked in JEE Mains 2019. Spring whose unstretched length is this is L1, okay, as L1 has a force constant K. The spring is cut into two pieces of unstretched length L1 and L2. So L1 L2 relation is given. What is K1 by K2? So I'll say K is inversely proportional to L. So if I say K1 by K2, so I'll say that is L2 by L1. Simple. Inversely proportional to length. So K1 by K2 is L2 by L1. L1 by L2 is 1 n. So L2 by N1 will become 1 by n. Directly we got 1 by n. Simple thing. Okay. We'll come to spring questions after some time. Now let us talk about the free body diagrams. So what is basically free body diagram is? A system is given to you where different masses are there, maybe placed on top of each other, different forces are acting, and then you need to analyze one of the block, find its acceleration, find the different forces that are acting, all those things. So what you need to do first, you need to draw the free body diagram. In free body diagram, what we will do is we'll separate the block first. Let us take, I need to draw the free body diagram of M2. So I'll draw it like this, M2. Now show all the forces on this M2. So I'll say one force is force due to gravity, M2G. Another force will be force due to M1. Okay, that is the normal force due to M1. Let us take that is N1, I'm saying. So I'll say this is N1. Another force will be force due to M3, M3 in the upward direction. Let us take this is my N2. Okay. Now when you are showing a block, you need to show the forces that are acting on the block, not the block is applying on other. No, force that are acting on the block. So on M2, M1 is applying force. You may say, sir, M2 is also applying on M1. Should we show? No, I'm showing the force on M2. So show the force M1 is acting on M2. Similarly, the force M3 is acting on M2. Similarly, any other force here, field force is there due to gravity. So gravity M2G is acting in the downward direction. So this we say this becomes my free body diagram. Now in another case, let us take here a sphere is there, two surfaces are there. Now let us draw free body diagram. One more thing, here I need to mention that when we show force between two surfaces, the normal force between two surfaces, here between M1 and M2, this force is always perpendicular to the surface. Okay, you cannot say that this force on M1 can be in this direction. No, that is perpendicular to the surface. This is the normal force. Okay, so similarly here if I draw the free body diagram, one force I'll show for this is mg, like this. Another force, the normal here. Another force, the normal here. Both will be different. Let us take n1 and n2. Another force, there might be some force due to friction also, but we are not discussing about friction till now. I'm considering this to be smooth. So you just show all the forces, okay, and then analyze the thing. Now let us talk about equilibrium. Equilibrium means generally here in laws of motion we'll only talk about translational equilibrium, but we know that equilibrium is of two types, translational equilibrium and rotational equilibrium. Rotational equilibrium we will talk in system of particles chapter. So translational equilibrium means the body is in translational equilibrium. So translational equilibrium basically when I say is the acceleration of the body is 0 or the force acting on the body is 0. External force, okay, when we say external force that is acting on the body, that is 0. That means this is the meaning of translational equilibrium. So I can say translational equilibrium force is 0, it means the acceleration is 0. Now force is 0 means the force in x direction is 0, force in y direction is 0, force in z direction is 0. So separately also I can say my fx is 0, fy is 0, fz is 0. It may happen there is equilibrium in one direction but not in other direction, it may happen. But when we say equilibrium, equilibrium means complete equilibrium. When we say equilibrium, it means that is complete equilibrium. Total acceleration is 0, total force along x-axis is 0, along y-axis is 0, along z-axis is 0. A body, if it is in equilibrium, is it required for the body to be at rest? Or it can be in motion also? One question for you. Can you answer in the comments? Okay, now listen to the reply. Equilibrium means the acceleration is 0. Acceleration is 0, the velocity can be there. If some particle is moving with a uniform velocity, I'll say that is an equilibrium, isn't it? Yes, that is an equilibrium. Okay, so equilibrium means acceleration is 0, force is 0, acceleration is 0, not velocity. Velocity can be 0, may not be 0. Okay, now let us solve some questions on equilibrium. One more thing, like as I mentioned, equilibrium means equilibrium along x-axis, force along x-axis 0, force along y-axis 0, force along z-axis to be 0. So we define x, y and z. And if you have to solve a question on equilibrium, and if it is convenient, you may take the standard x and y axis. If it is let us take not convenient that way, you may take other two perpendicular direction to be x and y, and then also you can apply equilibrium. Okay. So let us solve this question. For a free body diagram shown in the figure, the four forces are applied in the x, y direction. What additional force must be applied and at what angle with positive x-axis so that net acceleration of the body is 0. Now net acceleration of the body is 0, it means body is in equilibrium. So total force is 0, I'll say just F net is equals to 0. Okay, now these forces are acting, what additional need to be applied to make it 0? So I'll say that whatever is the force now, let us take the force is now my F plus I'll apply some additional force F additional. This total is equals to 0. Okay, so what is F now? Along x-axis let us talk about. So this is 5, this is 6, 1 will remain in this direction. This is 7, this is 8, 1 will remain in this direction. Getting it? So what is my force now? Minus I cap minus j cap, because one along negative x, one along negative y. If I put it here, this is my force, put it here, so my F additional will come out to be I cap plus j cap. And what is that? That is root 2 at an angle of 45 degree with positive x-axis. Okay, and you can just see this. This is 6, I need to apply additional 1 Newton in this direction. This is 7, I need to apply additional 1 Newton in this direction. So my additional force is 1 Newton in this direction, 1 Newton in this direction. So the resultant will be root 2 along 45 degree, the bisector of the two. So just root 2 along 45 degree. So visualization helps, like you need not write all the things. Another question. Block of root 3 kg is attached to a string whose other end is attached to the wall. An unknown force F is applied so that the string makes an angle of 30 degree with the wall. Yeah, the tension in the string is. Okay, now we need to find the tension in the string. Okay, so what I can do is, this point, is it, I'll say, I can make all the forces to be 0 at this point because the system is in equilibrium. Okay, so all the forces at this point I can make to be 0. So for, first of all, for this root 3 kg, if I talk about, force due to gravity is there in the downward direction. What is that? Root 3g. So in the, this block is also in equilibrium, so upward force will be root 3g. So tension in this string I got root 3g. So it means this, at this point, this string is pulling this point downward direction with a force of root 3g. And this string here is pulling this point in this direction with a force that is, we are considering T. And towards the right is F. Now take the components. If I talk about this angle, how much is this? This is also 30 degree. So take the components of T, vertical and horizontal, because I'll apply equilibrium separately along x-axis and separately along y-axis. Here it is mentioned that we need to find what? The tension T. Now along x-axis I can apply, but that is not needed. I don't need F. Only along y-axis I can apply. From there I can solve T. What is the component along y-axis for T? This is T cos 30. So at this point, upward force is T cos 30, downward force is root 3g, equate the two. So I'll say T cos 30 is equals to root 3 and g is 10. From there, I can put cos 30 as root 3 by 2. This root 3 is getting cancelled and we got T to be 20 Newton. A option. Okay, so we applied equilibrium along y-axis and from that only we solve for T. Now, analysis of accelerated bodies. Till now we discussed about equilibrium. Equilibrium means force is 0. We just made force 0 to solve some questions, and these questions were asked in JEE Mains. Now here bodies are moving, they are having some acceleration. So what we need to do? Then we need to apply the second law, F is equals to ma. Total force in a particular direction is equal to mass into acceleration in that particular direction. Okay, so we can apply separately also. Along y-axis we can say total force along y-axis is equals to mass into acceleration along y-axis, and along x-axis total force is equals to mass into acceleration along x-axis. So this is what we do. Now let us take here 3 blocks are connected. Now some force is acting 100 Newton and we need to find acceleration. So these 3 blocks are moving. If they are moving, they will be moving with the same acceleration. You can consider this to be just one system pulled by a force F towards the right. I can say acceleration of the system will be the total force towards the right divided by the total mass, that is 20 plus 20 plus 10, that is 50. I got my acceleration. Now you may ask, tell me what is the tension here in this? Now you just draw the diagram of free body diagram of these 2 blocks. Together you can make. Okay, so you see this 2 blocks together are pulled towards the right with a force T. This is my system now. Total mass is 20 and 20, 40, and it is moving with an acceleration that is 2 towards the right. So I'll say T is equals to mass into the acceleration, 40 into 2, that is 80. I got my tension T here. Now you may ask, tell me what is T here? Let's take this as T and this is T dash. So you may ask, what is T dash? So again I'll draw just this block 20 kg, it is having a force towards the right T dash. So I'll say T dash is equals to 20 into my acceleration, that becomes 40 Newton. Okay, so yeah, this is how we analyze. And let us take in this particular case, now here 5 kg, this 2 kg, and then this 5 kg, these are connected like this. A force to 40 Newton is applied towards the upward direction. Now you are asked, tell the acceleration. So you may say, this is my, these all 3 are moving with the same acceleration. Okay, so you can consider this to be one system. If this is one system, so this is total mass is 5 plus 5, 10 plus 2, 12. Now this 12 kg is there. Upward force is 120, sorry, 240. Downward force mg will be there. And how much is that? That will be 12 into 10. So 120. So if I need to write the acceleration here, so how will I say? Upward along y-axis I am writing now. Total force along y-axis is 240 minus 120. I'll say 240 minus 120 divided by my mass. That is total mass, that is 12. So this comes out to be 10 meter per second square. Okay. You may ask how much force C is applying on B. So just draw the diagram for B. This is my, let us take some force here. You may consider this force to be some F dash. Okay. This downward force, the force due to gravity only on B. So that is 50. And it is moving with an acceleration of how much? 10 meter per second square. So here write the equation along y-axis. So you'll say F dash minus 50 is equals to what? Mass 5 into 10. That is 50. So F dash comes out to be 100 Newton. You may be asked, what is the force A is applying on C? So just draw a combined diagram of C and because it is pulling C and B together. Or you may draw separately also. There you can separately show the force, other force due to B also. That also you can do. So same thing. Okay. So this is how you have to analyze the thing. I am just showing you how to analyze the things, how to show the forces, how to write F is equals to ma there, how to solve for tension forces or the force between the surfaces, like that. Okay. Now we got a similar question. 3 blocks ABC pulled in horizontal direction, smooth surface, a force of 80 Newton. Okay. The tension T1 and T2 in the strings are. This question was asked in 2023 January attempt. So quickly you solve this question and then come back to see the solution. I hope you are back. Okay. So first of all, just see how much, you can say how much acceleration of this whole system is there. All the 3 blocks are moving together. Total mass is 10 kg. Force is 80 Newton towards the right. So the acceleration will become 80 divided by 10, that is 8 meter per second square. Now to find T1, just see this 5 kg block. It is having a force T1 towards the right. It is moving with an acceleration of 8 meter per second square. So you will say T1 is equals to mass into the acceleration for this, and this becomes 40 Newton. So I got this as 40 Newton. Now you need to find T2. So you may just draw separate diagram for 3 kg or you can combine also C5 plus 3. Any one of the two you can do. So let us do separately for 3 kg. So for 3 kg, this force is T2. This force is T1 and we got that as 40 and it is moving with an acceleration of 8 towards the right. So you will say T2 minus 40 is equals to 8 into 3. So T2 is equals to 64 Newton. Okay. Or you could have done directly T2 is pulling these two blocks together. This is 5 plus 3, 8. So mass into the acceleration 8, that is 64. That way also we can say. Getting it? Okay, now we have a question on spring. Let us read. Find the acceleration of 3 kg mass when acceleration of 2 kg mass is 2 meter per second square as shown. So it is moving towards the right 2 meter per second square. Now here nothing is mentioned about the spring, the elongation there or the compression in this or the spring constant, nothing is mentioned. Now you need to understand the concept here. Let us take the spring is stretched. The spring is stretched. It will be applying a force kx on this in this direction. Similarly, it will be applying a force kx on this in this direction. Okay. Now, if I write for 2 kg block, Force towards the right I know, towards the left I know the acceleration. So let me write the equation. So I'll say 10, that is towards the right, minus kx is equals to mass into the acceleration 2. Now one thing you need to understand, many students do this blunder. Why writing this F is equals to ma equation? They don't care for the directions. They don't see in which direction the acceleration is there. They don't see whether we need to consider that as positive or negative. If the acceleration would be towards the left, I would be writing minus 2 here, okay, or I would be writing kx minus 10, any one of the thing. So you need to see, I considered right as positive, so I'm taking 10 as positive. Acceleration is towards the right, therefore that is positive. Kx is towards the left, therefore that is negative. You need to be careful, very careful, I'll say, with the signs. I wrote this, okay. So from here I got my kx. How much is that? That is 10 minus 4, that is 6. Okay. Now for 3 kg block, kx is acting towards the right only. There is no other force. So I will say, let us take this acceleration to be my a. Okay. So I will say that kx is equals to 3 into a. So what is kx? That is 6. This is 3 into a. So from here I got a to be 2 meter per second square. Getting this point? You have to be very careful with the sign. So don't get confused, sir. Do we need to consider this as positive or negative? Don't do this sign, okay? Sign mistake. Don't do this sign mistake. When I'm saying for here, let me repeat this thing again. Many of the students might still be confused. When I'm writing for this, okay, this is moving towards the right. I'm considering right direction as my positive. Therefore, I wrote 10 minus kx is equal to 2 into 2. Now, what if I consider the left as positive? Nothing will change, equation will be same, negative negative will be multiplied both the side. If I take left as positive, so I'll say kx minus 10 is equals to mass into acceleration is along minus, so minus 2. So minus minus will come both the sides. Nothing will change. Getting it? But one uniformity has to be taken. Like when you are taking right as positive, write this 2 as plus 2. Don't write minus here. Otherwise, the equation will be wrong then. Okay, another question. A monkey of mass 50 kg climbs on a rope which can withstand tension of 350 Newton. Maximum tension, he is saying that if this tension becomes greater than this, it will break. If the monkey initially climbs downward with an acceleration of 4 meter per second square, then climbs up with an acceleration of 5 meter per second square, okay, we need to find the tensions. Consider both the cases. Let us take, this is the monkey. Initially, it is climbing down with an acceleration of 4 meter per second square. What forces it will have? One force due to the spring, the tension force. Let us take this as my T1. Another force due to gravity, that is mg in the downward direction. So here, when I write the equation, what I'll say, I'll consider downward as positive, acceleration is in the downward. So I'll say mg minus t is equals to 4a. mg minus t1 is equals to my 4a, and from here I got t1 as sorry, I did a mistake. 4, oh, a was 4. Yeah, I did that mistake. m into a, this was m into a. Okay, a is 4. So I can just write t1 from here as m into g minus a. Okay. Now what is the value here? Mass is 50. G is 10, A is 4. So this is 300 Newton. So tension in first case is 300 Newton. Okay, none of the option is matching. Now the second case, it is climbing up. Again, draw the free body diagram. Okay, let us take this is monkey and it is moving up. Now in this case, it is having an acceleration of 5 meter per second. This is square. Okay. Yeah. I'm considering this to be T, this downward force to be mg. Acceleration is upward. I'm taking upward as positive. So I'll say, let us take this as my T2. Okay. So I'm taking upward as positive. Now in this case, if I write the equation, so what it will become? My T2, upward, downward is mg, this is m into a, my upward acceleration a. So this T2 will become m into g plus a. Getting it? M into g plus a. Now put the values to solve T2. So T2 will be m is 50. Okay. G is 10, A is 5. So 15 here. 750 Newton. Now here he was saying that can withstand only 350. So only maximum tension can be 350. So while going down it will not break because this is 300 Newton, but while going up it is 750 is needed, so it will break. So I'll say rope will break while climbing upward. One more thing, it's a common sense that when it will climb up then only the tension will be greater. There is no point of this, it will break while climbing downward. Okay, only climbing up. Okay, so he was saying will break while climbing, this should be downward. And one option should be downward. Will break while climbing. Yeah, so there was some typing mistake here. Okay, so only upward climbing only break. And one more thing, what is the weight? 500 Newton. So when it is at rest, it needs 500 Newton. Can the string provide? No. Even if it is at rest, it will break. So when it is moving, certainly it will break. Now we are coming to pulley problems. And pulley problems are, I'll say, very interesting problems, which many of you already understand the key concepts of the pulleys, but still let us quickly revise. So one thing is we consider string to be ideal and we consider the pulley to be ideal. String to be ideal means massless, inextensible. Pulley to be ideal means again pulley is massless and the friction on the surface of the pulley is negligible. We don't consider that friction, due to which the tensions on both sides is same. Here tension is same, here tension is same T. Here this tension is T, this tension is T. Here this tension is T, it will be pulling it with tension T. Getting it? Now, what if it is moving up with an acceleration A? So certainly this is heavier, so it will move downward. So if it is moving down with acceleration A, it will move up with acceleration, the same acceleration, because the same thread is there. Thread is inextensible, so it will move with acceleration A only in the upward direction. Okay. Now here you write the separate equations for both the blocks. Now here, this is my mg force. What is that? 30 Newton. This is also mg. This is 30 Newton. Now you write the equation and solve. I'll just, after writing the equations and solving these equations, I'll tell you a direct method to write the accelerations. So first of all, for this block, if I say it is moving upward, so this was 20. I did a mistake. This is 20. It is moving upward with acceleration A. So I'll say T minus 20 is equals to 2A. Okay. This is one equation. I can say T comes out to be 20 plus 2A. Another for this 30 kg if I write. So I'll say 30 downward force minus upward force T. This is equals to my 3 into A. And from there I got my T as 30 minus 3A. Now equate these two. This is 30 minus 3A, this is 20 plus 2A. Equate these two. From there you'll get 30 minus 3A is equals to 20 plus 2A. What it is now? This 10 is equals to 5A. A is equals to 2 meter per second square. And if I write T, this will become 24 Newton. I need to write equation, then need to solve, but we can directly also write. Okay, now let us try to write directly. Here, how we can write directly is, when I say acceleration, I'll say acceleration is my total pulling force divided by the total mass. Now, if you see, this 30 is pulling it down, this 20 is pulling it back. So pulling force will be 30 minus 20, means 3G is pulling it down, 2G is pulling it back. So Pulling force will be 3g minus 2g. What it will become? 3g minus 2g. That will become just g. That is my 10 divided by. What is the total mass? 3 plus 2. So this is 5. So I got my acceleration to be 2, which was this. Okay. I got my this answer directly here. Same thing. Okay. And then if I got A, you can write the equation and then write for T. Similarly here, in this case, if I say, first is, if it is moving down with acceleration A, this will also move in this direction with acceleration A, because acceleration will remain the same thread is connected, length of the thread cannot change. If this is A, this also is A. Now, write the equations for both the blocks. If for this 3 kg, if I say towards the right force is T, acceleration is A, so I'll say T is equals to 3A. For this, if I say downward force is mg, this is 20. So I write the equation. So that is 20 minus T is equals to 2A. These two equations are there. Solve this. Shift, put here T as 3A. So 20 is equals to 5A. A comes out to be 4 meter per second square. And T will come out to be 4 into 3, 12 Newton. But we could have written it directly. How? Just see what is the pulling force here. In this case, the pulling force here, that is in the downward direction, how much is that? 20. 20 is my pulling force. Okay, let me write that with different color. So here if I say F pulling, that is my 20. Okay, F pulling divided by total mass, 3 plus 2 is 5. 4 meter per second square. Directly I got it here. Isn't it? Directly I got it. So this way, when simple things are there, we can analyze. But if let us take a complicated, you can say structure is there, which is generally not asked in mains. But if let us take it is there, there you need to analyze things, and there may be difficult to directly write this thing. Okay, so in that particular case, the better way is to just, you can say, write the equations and then solve the equations, get your individual accelerations. That is the better way in that particular case. Okay, now let us take this pulley is here. This tension force is in the downward T. This tension force is also on this pulley is downward. How much will be the tension here? T dash, how much it will be? Pulley is massless, acceleration is 0, so total force has to be 0. Okay. So anyway, even if the acceleration is there, because it is massless, the total force has to be 0, because this is massless. Okay. So this is T, this is T, this will become 2T. Total force has to be 2T in the upward direction to balance it. Okay. Now coming to this question, can we do this with F pulling method, or should we do with just the fundamental method? So let us do first with the fundamental method. If this is moving with acceleration A, this will also be moving with acceleration A, and then you can write the equations for this block. If I write, so you'll say T is equals to 40A. For this, if you write, now here in this, how will you show the forces? Now you will say one force is the force due to this surface, normal force on this block. Another force is the force due to gravity mg in the downward direction. I need to study the motion along this, so I'll consider this. Okay, I'll consider the forces along this direction only, because the block will be moving in this direction. So I'll take the component of the forces along this direction. Now mg is like this. If I take the component of mg in this direction, what it will be? Mg sine 30, because this angle will be 60. Okay, so this is mg sine 30. Sine 30. If I take this component, this will be mg cos 30. So in this direction, if you talk about, this block is in equilibrium, this block is at rest. So in this direction I can say normal reaction is my mg cos 30. Okay, here I can say normal reaction is my mg cos 30. But that is not required here. We don't need to find that in this particular case. I just need to write equation in this direction. So let us take it is moving in this direction with acceleration a. So I'll say the force in this direction is mg sin 30 minus t is equals to mass into acceleration in that direction. I got this as my first equation, this as my second equation. I can solve these two equations to find the acceleration and the tension force. Now in this particular case, if I talk about F pulling method, what is the pulling force here? What is the pulling force? Here pulling force is mg sin 30. Pulling force is mg sin 30, and what is the total mass? 40 plus 10, 50. So I can say here acceleration will be my mg sin 30, mg sin 30, this is my pulling force divided by the total mass, that is 40 plus 10, that is 50. M you can put here, M is 10, okay. This is my 10. Same thing you will get by the equations also. T is equals to 40A you put here, this will become 50A there, 50 will come in the denominator. It's the same thing, same analysis by the two things, two methods. Now let us discuss about the constraint equation, okay. When multiple pulleys are there, when multiple blocks are there, how to relate their accelerations, and how to let us take find the individual values of the accelerations or individual tension forces there, okay. All those things we'll learn here. Now let us take, if I ask you, this is a pulley, here a block is connected, this pulley is moved up with an acceleration a, then what will be the acceleration of this block here? What will be the acceleration? Let us take this to be a dash. How much this would be? Now you have to see the string constraint. This length of the string will remain the same. If it is moving up with an acceleration a, let us take it came here. This distance, you can say this, the distance between the two centers to be some distance, let us take x. So the block has to come how much distance up? By distance of 2x, okay, because this is x. So here this length will come, that is x, here this length x, okay. So it will move with an acceleration of twice of that. So a dash will become my 2 of that particular acceleration of the pulley a, okay. Similarly, like you can see it, here this block is connected, okay, and now this is moved with an acceleration a. If this is moving with acceleration a, this end will move with an acceleration of 2a, okay. And similarly, I can say this is having some acceleration, let us take a, okay. This end is having acceleration a1, this end is having acceleration a2, okay. So a will be average of the two, so a will be equal to a1 plus a2 by 2. If direction is, any of the direction is opposite, you can consider plus minus sign accordingly, okay. So if in this case, if I say this is having an acceleration a in this direction, this end is having an acceleration a1 in this direction, and this end is having an acceleration a2 in this direction, then we will say a is equals to a2 minus a1 divided by 2, okay. So this is the string constraint. And now when there are, let us take in a system there are multiple blocks, and let us consider here another pulley connected like this. This is another block. Okay, let us take this is my acceleration A1, this is my acceleration A2, this is M1, this is M2. Now here, can we relate A1, A2? We can say this is moving with acceleration A1. So this is moving with acceleration A1. This thread, this pulley is at rest. If this thread is moving with acceleration A1, this will be moving up with acceleration A1. Okay. If this is moving with up with an acceleration A1, this is at rest because that is connected there. Okay. This is at rest. So what will be the acceleration here? This plus this by 2. So you'll say this is A1 by 2. Getting it? This will be A1 by 2. Now this you got by string constraint. If there are more blocks like that, that also you can analyze. But instead of doing all this, let me tell you a direct method to directly write the acceleration, directly write the relation of the acceleration. How? We will get the same relation. So first of all, what you do, you just mark the tensions. Mark the tensions. This is the diagram. Mark the tension. Now this is a single thread. Single thread will have a single tension hole throughout. This is T. This is T. This is T. This pulley total force will 0. Total 2T downward, 2T upward. So 2T. On this pulley, 2T upward, total force has to be 0. So 2T downward. So on this block M2, this 2T upward, 2T. Now, what we need to do is, we need to do summation of T dot A for all blocks to be 0. This we need to, I'll tell you from where we got this. First of all, let us write it. Dot product we have to take. Okay. Now this T is upward direction, A1 is in the downward direction, angle is 180 degree. When you take the dot product, cos 180 will be 0. T dot A is TA cos theta. You know that? So T into A1, T into A1 cos 180, so minus 1. For this block, if you write 2T in the upward direction, A2 in the upward direction, angle is 0 degree. So this dot product will become 2T into A2. So plus 2T into A2 is equals to 0. And from here, I got my A2 to be A1 divided by 2. Okay. I got my T2 to be, A2 to be A1 divided by 2. I got this relation directly from here. So when multiple blocks are there, multiple pulleys are there, better method is this. Because instead of analyzing, now if I make a bigger network of this, so for each point you need to see what is the acceleration, what is the tension, and then you need to relate. So that takes a lot of time. This is the shortest and the quickest method. Okay. And now if I have to solve for acceleration, how will I do now? I got the relation A1, A2. Now individually write the equations for each block. Here for this block if I write, okay, for this block M1 if I write, how will I write? T is in the upward direction, M1G in the downward direction, force due to gravity, and it is moving with an acceleration A1 in the downward direction. So how will I write force acceleration equation? So I'll say M1G minus T is equals to M1A. M1 A1. First equation we got. Now for this M2, 2T in the upward direction, M2G in the downward direction, this M2G in the downward direction, and it is moving with an acceleration A2 in the upward direction. So write it now. This I'll say 2T minus M2G. This is M2 A2. Now A1 A2 relation I know, so I'll put this A2 here. This A2 here I'll replace with A1 by 2. And then I'll solve the two equations. I'll get A1, I'll get A2, I'll get T. So this is how you have to do any pulley problem is there. Any pulley problem is there. First step is mark all the tensions. Second step is make T dot A to be 0 for all the blocks. Third step is write the equation for each block. Fourth step is solve the equations, you'll get all the answers. This is the steps you have to follow. Again, I am repeating. The first step is mark all the tensions. Second step, make T dot A equal to be 0, summation of that. Third, individually write for each block F is equals to MA equations. And the last step is solve the equations. This is for M1, this was for M2. Any question, any pulley block question is there. This is the where you need to find the acceleration, where you need to find. So just this way you do. Okay, multiple pulleys are there, some fixed pulleys are there, some moving pulleys are there. Okay, so this is the standard way. Now you may say, sir, why, how we got this summation of T dot A to be 0? Now I can say that actually the work in a system, work done by internal forces is 0. In work power energy, you'll understand what is work done. So in a system, the work done by the internal forces is 0 because these are equal and opposite forces. Okay, so internal forces, the work done is 0. So work the forces will do on M1 and M2 because these two blocks are only having masses. Okay, pulleys are ideal. So work done on these two will be 0. So when you write the equation for work done, you write F dot X, force dot displacement. Okay, but if you differentiate it twice, you'll get dot acceleration. Okay, so I differentiate that twice, therefore I got summation of T dot A. T is my internal force, tension is my internal force, therefore I am writing summation of T dot A to be 0 for all blocks. Now further, motion of connected bodies not moving along the direction of tension in string. So sometimes what happens, there is a block, okay, or there is a hell ball, it is moving in this direction, moved with some external force or like that, or it is placed on surface, the block is released, now it moves along this surface, this block will move in the I'll say vertical direction. So there we need to relate the accelerations, there we need to find the tension forces, all these things. So how to do that? The string constraint is the key. String is inextensible. String length will not change. So the component of velocities along the string will remain the same. String length will not change. So the component of velocity along the string will remain the same, or I can say component of acceleration along the string also will remain the same. If let us take at any instant it is moving with velocity v1, it is moving with velocity v2. How to relate v1 and v2? Component along the string. So v1 is in this direction along the string. If you take the component, this angle is theta, so this will become v1 cos theta, v1 cos theta. So if I write this component will be my v1 cos theta. This is v2, this is along the string only, this is v2. So I'll say along the string will remain same because length of the string cannot change. Length of the string cannot change, therefore these has to be same. So I'll say that v1 cos theta is equals to v2. And if I differentiate it, this equation again to relate the accelerations, I can say a1 cos theta is my a2. And then you can write the equations of the forces for block and for this particle, and then you can solve whatever you want to get. Okay, now coming to the questions of pulley problems asked in mains. So this question was asked in January attempt of 2024. Let us read it. The light string passing over a smooth light fixed pulley connecting two blocks of masses m1 and m2. If the acceleration of the system is g by 8, the ratio of the masses is. I need to find m1 by m2. The acceleration is given as g by 8. How to relate? Just write the acceleration individually, write the tension forces and other things. One of the masses you can take as heavier. It's not mentioned which one is heavier. You may take one of that is heavier. You may take m2 to be heavier. Okay. So it is moving down with acceleration a. It is moving up with acceleration a. This tension is t. This tension is t. Write the two equations, solve for a. Or Just see the pulling force. What is the pulling force? M2G minus M1G. So M2 minus M1 into G. This is my pulling force divided by total mass, that is M1 plus M2. And this is given to us as G by 8. This got cancelled. So I got from here 8M2 minus 8M1 is equals to M1 plus M2. So 9 by 7. He's not saying, he's not giving the option like 9 by 7 and 7 by 9. No, because he's not saying which block to which block. Anyway, okay. So simple thing. Either you solve the equations or just you write pulling force divided by the total mass. Get the answer. Okay, another question. All surfaces shown in figure are assumed to be frictionless and the pulley and the string are light. The acceleration of the block of mass 2 kg is. We need to find the acceleration of this block of mass 2 kg. How to relate now? This is a one pulley is moving, another pulley is stationary. Okay, blocks are moving with different acceleration. So what we need to do? Mark the tension forces first. I'm considering this tension force to be T. So this is T. This is T. This is T. This is 2T. I need to find the acceleration of block of mass 2 kg. Let us take this is my A1. Let us take this as my A2. Summation of T dot A is equals to 0. So this will become T into A1. And this is 2T upward, A2 downward. So minus 2T A2 is equals to 0. So A2 is equals to A1 by 2. Got it. Next step is relate write the force acceleration equation for each block. Okay. So for 2 kg, which forces are there? Downward force mg is there. So along the surface, if I take the component, so this will become mg sine 30. Okay, vertical component will also be there, mg cos 30, which is equal to the normal reaction, but I don't need that. So if I write the equation here, I'll say T minus mg sine 30 is equals to 2a. So T minus mg sine 30 is equals to 2a1 ma. Okay, ma. So m is 2. So here also I should write 2 instead of mg. So this is 2g sine 30. This I wrote as 2. Now for this block, if I write, it is having a force in the downward direction as 4g due to gravity. 2t is upward, moving with the downward acceleration of a1 by 2. So 4g minus 2t. 4g minus 2t is equals to 4g minus 2t is equals to 4 into a1 by 2. a2 is a1 by 2. So 4 into a1 by 2, that is 2a1. Wrote it. So from one of the equation, I'll put t. I can put t in the second equation, can solve for a1. Okay, let us do that. What is t? 2a1 plus 2g sine 30. So 2a1 plus 2g sine 30. Sine 30 is 1 by 2. So this is plus g. This is my t. So twice of this I have to put here with a negative sign, plus 4g. This is plus 4g. This is my 2a1. I hope everything is fine here. Is there any mistake? Let me know in the comments. Comments are not live. Okay. So from here I can write a1. What is, how will I write? This is 2g, this is 4g, minus 2g, 4g. So this will remain 2g here. 4g minus 2g, that is 2g. And this will become 2 plus 4, that is 6a1. So from here I got a1 as g by 3. B option. Few steps in this question, but will not take much time when you are a bit quick. Another question. A uniform metal chain of mass m length L passes over a massless frictionless pulley. It is released from rest with a part of its length L is hanging on one side of its length, L minus L is hanging on other side, okay, L minus L on the other side of the pulley. At a certain point of time when L is equals to L by X, the acceleration of the chain is G by 2, the value of X is. Now, this chain is a uniform chain. You may consider it's like two blocks, one block on one side, having the mass equal to this mass of this chain, another block on other side having mass equals to this mass. Using these two masses you can write the acceleration, isn't it? So let us take this mass to be m1 and this mass to be m2. So I'll say here acceleration as pulling force m2 minus m1 into g divided by total mass m1 plus m2. This acceleration is given as g by 2. So the relation of m1 and m2 we got from here. Okay, can we write? Yes. So this is 2m2 minus 2m1. This is m1 plus m2. From here I got m2 is equals to 3m1. This relation I got. Okay. Now what is m1? This chain is a uniform chain. It is mentioned uniform metal chain. So mass, when I say, this will be mass per unit length into the length. So when I say m1, m1 will be mass per unit length. Let us take that as lambda into L. m2 will be mass per unit length lambda into L minus L. Put it there. So m1 m2 is lambda into L minus L and m1 is lambda into L. Lambda will get cancelled. Lambda will get cancelled and L comes out to be 4L. So L is basically capital L by 4. X comes out to be, okay, value of X is 4. Okay, these options are by mistake here. So value of X comes out to be 4. You got it? Okay, this was another straightforward question. Actually, not much difficult questions are asked in mains. Therefore, I am saying not much difficult. Just understand the concepts. Your concepts are fine. You can solve any question in mains. The boxes of mass 2 kg, 8 kg, this is 2 kg, this is 8 kg, are connected by a massless string passing over smooth pulleys. Calculate the time taken by box of mass 8 kg, okay, to strike the ground starting from rest. So how much time it will take? From rest I am releasing. So what you will do? Find the acceleration, write the distance as half at square, because starting from rest, from there you write the t. Okay, so this is what you need to do. You need to write, find the acceleration of this block, find the time. Can you do this? Okay, so take a pause in this video, solve this question, comment your answer so that you can like check after it, okay, what you mentioned there. So comment your answer and then come back to the discussion. Okay, I hope you are back now. So let us find the acceleration. First of all, mark the tensions T, 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 2T. Make T dot A summation to be 0. I am taking, let us take this acceleration as my A1 and this acceleration as my A2. Making T dot A, summation of T dot A to be 0. So 2T upward, A1 downward minus 2T A1 is equals to, this is minus 2T A1 is equals to, for this block, T upward and A2 upward. So what it will become? This will become T into A2 plus T into A2, not equal to there. So plus T into A2 and this is 0. So I got A1 as A2 as 2A1. I'm putting A2 as 2A1. In these type of things you can directly also see, okay, this thread will have here, this point will have acceleration half of that. So that you can directly also see, but I'm showing you the method, proper method, so that you can even write these relations in complicated pulley block problems also. Wrote it. Now write the equations for each block. So for 8 kg block, if I say this will be 8g downward force minus 2t upward force. This is m into a, so 8a1. For this block, 2 kg block, so t minus 2g, this is equals to 2 into a2. Okay, that is t minus 2g, yeah, that is 2 into a2, and from here t comes out to be 2 into g plus a2. a2 is 2a1, so 2a1, and put this t here, solve that further. Also this 2, this will become 4, this will become 4. Now writing that, so this will become 4g minus t. So what is t? That is 2 twice of g plus 2a, 2a1, and this is equals to 4a1. 2 here, and this is also 2. So 2g minus g, that will become g, and this is minus 2a1, and this is 2a1. So a1 will become g by 4. I got the acceleration. I know the distance, I know the acceleration now. So I'll say s is equals to half a t square. Okay, what is s? S is my 20. 20 is 1 by 5. 20 is 1 by 5, na? Yeah, not 20 is 1 by 5. 20 centimeter is 1 by 5 meter. So 1 by 5, converting that to meters. Okay, so 1 by 5 is equals to, this is 10 here, g is 10 divided by 2 into 4, this is 5 into t square. So from here t comes out to be 2 by 5, that is 0.4 seconds. 0.4 seconds, B option. Takes a bit of time in this question, but not that much. You can quickly just increase your speed of writing the equations. So these type of questions should not be skipped. Many of the students will miss while writing the equation, or they may commit some mistake even. Okay, now wedge constraint. Let us take here, we are having two wedges, 1 and 2, and they are moving like this. Now this second wedge is constrained to move in the vertical direction only, because these two, I can say, walls are there, or two supports, rigid supports are there. So this block 2 will move only in the vertical direction. This block 1 can move in which direction? Only in the horizontal direction, because ground is there. It cannot move in the vertical direction, only horizontal direction. So this will have only vertical velocity, this will have only horizontal velocity. This is the constraint. Okay, this is the constraint. But how to relate their velocities or their accelerations? Let us take, it is moving with acceleration in this direction a2, and this is moving in this direction a1. How to relate? Now I am going to speak a conceptual point, and that is, their contact is maintained. If their contact is maintained, the velocity or the acceleration along the direction perpendicular to the surface will remain the same. Perpendicular to the surface of contact will remain the same, because that surface is not separated. If that surface is not separated, the component of acceleration along that has to be same for both, means the relative acceleration is 0 in that direction, I am saying. So in which direction? Perpendicular to this, in this perpendicular direction. Let me draw it with the dotted line. In this direction, perpendicular to it. So components of a1 and a2 in this direction. So this is my a1, or I'll say this to be the line perpendicular to the surface. So I'll say the velocity along that has to be 0. It means the velocity of separation is 0. They cannot be separated, or the acceleration, means if you differentiate, you get the acceleration. So the acceleration has to be 0, okay, along that. Therefore I am saying component of that will be equal. So a1 component along this, what it will be? This is theta, this is theta. So this will be a1 sin theta. So if I write this component, this will be my A1 sine theta. Now, if for let us take A2, if I say A2 is downward, so A2 is this. Now take the component of A2. What is this theta? This is theta. So that is A2 cos theta. So along that line, the component of A2 that we are getting is A2 cos theta. So this is A2 cos theta. The accelerations has to be equal. So A1 sin theta is equals to A2 cos theta. And from here I can say that my A1 by A2 or A2 by A1, anything you can write. So I can say A2 by A1 comes out to be 10 theta. Don't remember this formula. You may get confused which was theta, which was A1, which one A2, and even the constraint may be different. But you have to say that this is my line of separation, because if separation happens, that will be along that. So accelerations component along that has to be same, because the separation is not happening. That is the concept. Okay, now we are going to discuss one of the most confusing part of this chapter, and that is pseudo force, and many of the students are confused, and let me make very simple for you this pseudo force. Now when we write equation F is equals to ma, that we write in inertial frame. In simple words, I'll say in frame of ground. Okay, we are sitting on the ground and we are writing that equation. Okay, inertial frame means the frame which is having zero acceleration. It may be having some velocity, but inertial frame means the frame which is having zero acceleration. Okay, but let us take, you are moving on, you are sitting on a bike. This bike is accelerating, is having some acceleration. Now you are seeing some force on a block and you are writing the equation for that. The acceleration you will write, that will be wrong. That is not in frame of ground, that is in your reference frame. So there, if you write the equation, the answers will be wrong. So there, what you need to do, you need to apply pseudo force. So pseudo force we apply for non-inertial frame of reference. For non-inertial frame of reference, we apply pseudo force. Okay. Not for inertial frame of reference. Now, non-inertial frame of reference example is here. Now, this person is sitting on the ground. He's a block is there on the left, okay, attached at the ceiling of the lift. This lift is moving upward with acceleration a. This person is standing on the ground. He is observing this block. When he will write the equation, if he will write the equation, he will say block is having some tension force in the upward direction, some force due to gravity in the downward direction, moving with acceleration a naught with respect to ground. So he will write the equation that tension force minus mg is equals to ma naught. Now let us take this person who is standing inside the lift. If he tries to write the equation, he may say block is at rest, because the block is always in the front. Block is at rest. So he may say that this tension force is there, downward gravity is there, if block is at t is equals to mg. Will that be correct? No. If he will write the equations like that, those equations will be incorrect. He will say one tension force, downward mg, acceleration is 0, t is equals to mg, but that is incorrect. Why incorrect? Because it is not inertial frame of reference. This is non-inertial frame of reference. This person in itself is having an acceleration in that direction, a naught. Okay, so he cannot write that equation like this. What he needs to do, what changes he need to do? He needs to apply a pseudo force. Okay, so for this person, so for when this person will see, now let us take, this person takes a help of a teacher, and that teacher tells him, you are accelerated frame of reference, you need to apply a pseudo force, otherwise the equations will be wrong. Now what he will do, he will apply a pseudo force. What pseudo force? What is pseudo force? In which direction he need to apply? Now it is having an acceleration a naught upward, in the upward direction. He will apply a pseudo force in the opposite direction of the acceleration, and that force, pseudo force, is equal to mass of the body into the acceleration of frame of reference. Iska acceleration means the acceleration of this person, that is a naught. So that is the pseudo force you need to apply. Now he is saying this acceleration is 0. Now he can write the equations. Now if he write the equation, now he will say tension is in the upward direction, force due to gravity, and pseudo force is in the downward direction, and the block is at rest. I'll say perfect. You wrote it properly. So what equation this person B will say? Person B will say tension is in the upward direction, mg is in the downward direction, and pseudo force is in the downward direction. Let me write its value itself here. And the block is at rest, so mass acceleration is 0. Therefore he will say from here T is equals to m into g plus a naught, and this person A, when A was saying, he was also saying T is equals to m into g plus a naught. Now they are in line. You see, now they are in line. So for non-inertial frame of reference, you need to consider pseudo force. Are pseudo force question asked in JEE means? Not very much. Not asked actually. I'll show you one question that you can solve by ground frame also, you can solve by pseudo force method also. But if this is, I'm just telling you a concept. I hope you understood the concept in simple words. But if you still you are not getting, you can skip it. Pseudo force, you can skip it for means as of now. I will solve a question. I'll take help of pseudo force in one of the questions that were asked in mains, but not very frequently this is asked. Okay, let us discuss this question. Three masses m, that is 100 kg, m1 that is 10 kg, m2 which is 20 kg are arranged in a system as shown. The surfaces are frictionless and strings are inextensible and weightless. Means he is saying just the ideal conditions. Okay, the pulleys are also weightless and frictionless. A force F is applied on the system so that mass m2 moves upward with an acceleration, moves upward with where I was, yeah, with an acceleration of 2 meter per second square. Okay, the value of F is how much this F should be such that the acceleration of m2 in the upward direction is 2 meter per second square. Okay, now let us analyze this system. First of all, in ground frame, when you push it, this block 100 kg will move towards the right, and here also will be force on the other block. The other block m2 will also have the same acceleration in the horizontal direction. Acceleration of m and m2 in the horizontal direction will be same. Okay, getting it, getting that point? Yeah, so in the horizontal direction their accelerations will be the same. Now if I see the system of this block and this m2, okay, see this system, this is pulley is also attached with this block. So one force, tension force is this, one tension force is this, downward direction, one in the horizontal direction. Okay, and this m plus m2, I'm just drawing it combined. This m plus m2, a force F is there and they are moving with some acceleration. Let us take A in the horizontal direction. So in the horizontal direction, if I write the equation, I'll say F minus T is equals to total mass m plus m2, that is 120 into A. This is this equation I wrote in the ground frame. Okay, now this m2 is having an upward acceleration of 2 meter per second square. So if it is moving upward with respect to this block, this is moving only in upward direction. With respect to M2, with respect to capital M, M2 is moving only in the upward direction, okay, because horizontal they will have the same acceleration, so relative acceleration will be only in the upward direction. So if I make this as my reference, okay, this is my reference. So M2 is moving with an acceleration 2 meter per second square in this direction, and this block M1 is also moving with 2 meter per second square in this direction. So its acceleration is this direction, its acceleration is in this direction, and this is 2 meter per second square, because the thread is the same, thread constraint is there. Both will have the same acceleration like this. I'm making this as a reference. Now, if I'm making this as a reference, I need to apply a pseudo force also. Yes. On this block, if I apply a pseudo force, that will be in this direction, and that will be its mass, that is 10, into the acceleration A. Because it was having towards right acceleration, so force will be applied towards the left. Similarly, you need to apply pseudo force on M1 also, okay? M2 also this. So M2, one force is the normal force in this direction. Another force is the pseudo force now in this direction. And what is this pseudo force? M2 into A. M2 into A. What is this normal force? In frame of reference of ground only, if you see, in the horizontal direction, N is equals to M2 into A. So this is also M2 into A. Anyways, these two forces are 0, cancelling means the net is 0, they are cancelling each other. That's why only vertical motion is there with respect to this 100 kg block. Getting it? Now, if I write the equation for these two blocks, they are moving with an acceleration of 2 meters per second square in this direction. So total pulling force will become 10A is this, and this downward force M2G, so minus 20G. This is the total pulling force. And what is the total mass? That is 10, that is 10 plus 20, 30 by 30, and this is my acceleration, which is 2. Acceleration is 2. Okay, anything else? Nothing. So I got from here that 10A comes out to be 60 plus 200. So 10A is equals to 260. A comes out to be 26. A is 26. Now what I need to find F. For that I need T also. To find T, you can write equation for one of the block in frame of reference of this only. So one of the block means, let us write with for this block M1. So on this block, one force T is in this direction, another force 10A is in this direction. It is moving toward the left with 2 meter per second square. So I'll say 10A towards the left, 10A minus T, okay, and that is equal to my 10 into 2, 20. So T comes out to be 10A, yeah, 10A minus 20. Everything is fine. Yeah, 10A minus 20. What is A? A is 260. A is 26. So 260 minus 20, 240. Put it here. From here, I'll get T as 240 plus 120 into A, that is 26. And if you solve it, you'll get A as the correct answer. Okay. Yeah. Now, here we need to take the help of pseudo force to make it easy. Otherwise, in ground frame, if you try to write the equation, it will take you longer time. Therefore, I took help of pseudo force. But these type of questions are not very frequently asked. I'll say very less they are asked. Hardly there are few questions where we need to take help of pseudo force in mains. Now, weight in an elevator. Sometimes a question is asked, a block is kept on the surface of an elevator, okay, and now the elevator is moving upward with this acceleration. What will be the weight, effective weight? It is moving in the downward direction. What will be the effective weight? So what is that? Let us discuss this. Okay, let me take another shape. square. Let us take this is my elevator, and on the surface of the elevator a block of mass m is kept. Now conditions may be some acceleration a is there. Case 1, I'll say a is 0. If a is 0, it is having two forces, I'll say one force mg, another force normal force. So you'll get normal is equals to my mg, simple. So here weight will be mg, okay, the effective weight is mg in itself. Now case 2, you may say it is having some upward acceleration. Case 2, it is having some acceleration upward, acceleration a, like this. So here you will say it is moving upward also, acceleration is a. Now if you write the equation, you will say n minus mg is equals to ma, and you will say your n comes out to be m into g plus a. This becomes your effective weight, m into g plus a. Another condition can be case 3. Here let us take it is moving downward with some acceleration a. Moving downward means it is having an acceleration a like this, okay. So if it is moving downward with acceleration a, you will write the equation. What you will say? You will say mg minus n is equals to ma, and your n comes out to be m into g minus a, okay. So if it is at rest, mg effective weight is this. If it is moving upward, it will become m into g plus a, and if it is moving downward, it will become m into g minus a. So we will say when it is moving upward, my effective g becomes this. This is my g effective. When it is moving downward, my g effective is this, okay, and it is at rest, g effective is g. Getting it? Moving upward, it will become g plus a. Moving downward, it will become g minus a. A question asked on this topic, let us write it. A person standing on a balance inside a stationary lift measures 60 kg. The weight of the person if lift descends with uniform downward acceleration of 1.8. So acceleration is downward, my n will become m into g effective, g minus a. What is m? M is 60, g is 10. What is a? A is 1.8. Everything is fine, yeah. So this will become 60 into 8.2. So this is 82 into 6. What is this? 6 into 2, 12, 49. So 492. 492. This type of question was once asked in JEE Advanced only recently. I think, yeah, this year only. Yeah. So there was also effective weight. It is moving upward with acceleration a. It is moving downward with acceleration a. There the effective weight was we need to find. So just simple m into g effective. If it is moving upward, g effective g plus a. If it is moving downward, g effective will become g minus a. Okay. Now deviation of string inside a vehicle. So let us take a car is moving. Initially I am saying let us take this car is at rest. String is like this, mass is m. We'll say the string will remain vertical. Now you gave an acceleration a in the horizontal direction. So what will happen? The string will tilt, isn't it? With the vertical by some angle like this. Let us take this angle is theta. So now we need to find theta. We can write in two ways. Ground frame also we can write, and we can write in frame of cart also. There we need to write apply pseudo force. Anyways, I'm going in ground frame for you to understand in a better way. So here this tension force is T. Let me take another color so that you can visualize it. This tension force is T. Any other force? Any other force is mg? Any other force? No. Take the component of T in the vertical and in horizontal direction. So in vertical, if I'm drawing this as vertical, this angle will be theta itself. So upward, vertical upward will be T cos theta, horizontal will be T sin theta. So this horizontal is T sin theta, this upward is T cos theta. Okay. So in the vertical direction, is there an acceleration? No. So I'll say that T cos theta, this is my mg. In the horizontal direction, is there an acceleration? Yes. What is that? A naught. So I'll say T sin theta is equals to A naught. M A naught. T sin theta is equals to mass into acceleration M into A naught. Divide these two equations. So you'll get A naught by G. This is my tan theta. Okay. Or you can say that A naught is equals to G tan theta. You can do this in frame of cart also. In frame of cart, let us do that for you to understand that in a better way. I'm doing that also. So in frame of cart, what are the forces? One force, this tension force in this direction, another force, this mg force in this direction, another force, pseudo force in the backward direction, m a naught, and you will say its acceleration is equals to 0 because you are in frame of cart. So this is in frame of cart. This was in frame of ground. Now here again taking the components T cos theta and T sin theta. So in the vertical direction, if I say my T cos theta is mg, in the horizontal direction T sin theta is equals to ma. Dividing them, you will get the same thing. Divide the two, tan theta. This was a naught. Oh yeah, I missed it. It should be T cos theta is mg and T sin theta. T sin theta is m a naught. Yeah. M a naught. This is mg. So tan theta will become a naught by g. Same thing you are getting by these two ways. Okay. Now, case of spring balance. Let us take a block is connected like this with a spring balance. So if I say that on the block a downward force mg is there and an upward force will be forced due to the spring. So downward force mg is there, upward force is the force due to spring. Force due to spring is, let us take elongation is x, so this will become kx. So here I'll say my kx is equals to mg. You get your elongation, okay, and accordingly we get the weight. Like the marking is there, if this much elongation is there, so weight is this. If this much elongation is there, the weight is this. If this much elongation is there, the weight is this. So this is how we measure the weight by spring type of weighing system you might have seen. So if let us take, if we connect two, so what change will happen? We have connected two in series like this. So here this is my spring force kx, this is mg. Here also it will remain the same, kx is equals to mg. Okay. Now considering spring to be massless, How much force this will apply on this? It will be also mg in the downward direction. Here also I'll say kx is equals to mg. Okay, and let us take it is connected like this. So this is one force mg in this direction, this tension force T. So this T is mg only because this is at rest. So it should be equal to the spring force. So I'll say kx is equals to mg. Same thing here, okay, the same thing. It will be having a force in this direction, that is mg. Okay, and then you can again write the same thing. So this is how basically we measure the weight of a block. So some weight is there. So generally you might have seen people like having that spring balance uh, kind of weighing machine. So what they have do is there is some like some instrument, not instrument, there is a hook kind of thing. Okay, like here we are having, there is a hook kind of thing. So you put the weight in that, you put the weight, hang the weight with that, and due to this it will be elongated. The spring will be elongated in this. So when the spring will be elongated, there will be a mark on the spring. Okay, here there will be mark, the mark will go like this. Okay, and there will be marking like 1 kg, 5 kg, 10 kg, like this the marking goes. Okay, it stops at 10 kg, so I'll say this mass is 10 kg. Okay, this is how it is used. Now cutting of springs or strings. Sometimes a question is there like blocks are there, some spring is there, one of the string is cut. Now immediately after cutting, tell the acceleration of A, tell the acceleration of B. Such type of questions are asked. Now the point is, when we cut the string, the tension force in the string will change immediately. In the string, the tension force will change immediately. If you cut the string, tension becomes 0 immediately. But the problem with the spring is it takes time for the spring to elongate or to compress. Spring elongation compression will not happen immediately. If you cut it from here, this B block will not come to know it is cut at this instant or not. After some time he will come to know, okay, that string is cut, because the spring is not compressed, okay, back automatically, or I'll say instantaneously. It will take some time, slowly it will happen. Okay, so the effect on B will not come instantaneously. So just after cutting, if you ask me what is the acceleration of B, I'll say its acceleration is 0. Initially it was at rest, just after cutting it will remain 0. Now just after cutting, what is the acceleration of block A? Now for A the acceleration will come. One spring force is there in the downward direction. Okay, that is my Kx. Another mg is there in the downward direction. Initially T was there, tension was there in the upward direction, okay, which was balancing these two. Now that tension force is not there, this tension becomes 0. Now it will be having some acceleration in the downward direction. That will not be 0 for that block. Similarly here, if you talk about, you are cutting the string, acceleration of B will remain 0. I am talking about just at the instant of cutting. Okay, try to understand this. I am talking only about just at the instant of cutting. Just at the instant, not after some time. So acceleration of block will remain 0. Why so? It is connected with the spring. Spring elongation compression will not change immediately. It will remain like this. For A, yes, it will not be 0. For A, we need to find. That will not be 0. Okay, now we are going to start the next major topic of this chapter, that is friction. And friction, I'll say, is very important key topic of this particular chapter. Many times the questions are asked from friction, both in mains as well as in advance, and sometimes the question is mixed with the concepts of other chapters as well. So friction is, I'll say, very important. So what basically friction is? So as we know, like when two surfaces are there, let us say I'm putting a block on a surface like this. You are trying to apply a force F. You will say F is applied, acceleration will be m into a. In real life, it's not like that. Why so? Because in real life, if you talk about, the surface will be somewhat like this on micro level. Similarly, the surface of the block upward will be somewhat like this on microscopic level. And when you try to move it, okay, there will be a force, okay, due to this, okay. So that force we call as the frictional force. It try to oppose here. That is my frictional force. Getting it? Now frictional force is also of two types. It can be kinetic, it can be static. Static means there is no motion between the two surfaces. Let us take, you are trying to move the block, but the block is not moving. Will there be friction force? Yes, friction force is there, it is opposing it. Force is there. So that is opposing it. Okay. So that friction we say that is static friction, when there is no relative motion between the surfaces. When there is no relative motion between surfaces. And kinetic is when there is relative motion. So this is very important. Whenever we will solve a question, we need to identify whether the friction is of static nature or is it of kinetic nature. Now, if it is of static nature, there is no relative motion between the two surfaces. The two surfaces might be moving together, okay, but there is no relative motion between the two surfaces. Then we say this friction is static. If the two surfaces are moving together, there is no relative motion, the friction is still static. Sometimes somebody thinks like static means no motion at all. No, it can be motion, but if there is no relative motion. Kinetic means there is a relative motion. Kinetic friction is having constant value of friction force. Static friction, we say it is less than equal to, will come about what? Will come to what it is less than equal to. So static friction, first of all, as we wrote, there is no relative motion. You are trying to move a block by applying a force on this, but it is at rest. So I will say that yes, there is a friction force in the backward direction which try to oppose it on the block, okay, and this is my static friction force. As the acceleration of this block is 0, so as the acceleration you applied a force F, okay, so as the acceleration is 0, both the forces are equal. Your applied force is equals to F static. You are slowly increasing the force, static friction force is also increasing unless a upper limit comes. When an upper limit comes, until, okay, so when the upper limit comes, after that you increase, it will start moving. So we will say that then the friction becomes kinetic. So here I will say that F static, my static frictional force, is basically equal to, or I will say less than equal to, mu into n. Mu is mu s, that is my coefficient of static friction. Coefficient of static friction. And what is n? N is the normal reaction or the normal force from the surface. When this block will start moving, what is the normal force? To find the normal force, just draw the free body diagram of the block. Let me take this color. This is my block. One force mg, another force normal in the upward direction in this case. We are applying this force F here. This is my friction force which is trying to oppose. So in the vertical direction the acceleration is 0. So I will say that my n is equals to mg. So here my F static is less than equals to mu static into mg, coefficient of static friction into mg. This is my static friction force. So maximum value of the force static friction is mu mg or mu s mg. Getting it? Maximum value is coefficient into mg. If you cross this maximum value, then the block will start moving. Till this block will not move. You try to increase F, this friction force will also increase. You increase it F, further it will increase. You increase this F beyond mu mg, it cannot increase. It will go till there only. And after that, the friction will change. Then the kinetic will come. Then kinetic friction is constant. We'll come to that also. Okay. So this is the important point. Now, many times questions are asked. Friction is static there in nature, and then it is asked how much is the friction force, and then what students do? Mu mg. Oh, just see, the block is not moving, the friction is static. Static friction is less than equals to mu mg. The maximum value is mg, mu mg. The maximum value is mu s into mg. Okay, but it's not that static friction is mu mg. Okay, static friction, you need to see the condition. Here we can say my static friction is basically equals to F. If acceleration is 0, the static friction is equal to F. Okay, now kinetic friction. Kinetic friction when there is relative motion between the two surfaces. So if relative motion is between the two surfaces, I can say, let us take, I increase the value of that friction force beyond the maximum value of static friction, and then this block started moving with some acceleration a. Okay, and now I'll say one force, this mg, this force in the upward direction normal, and this is my friction force. Let us write this as Fk, F kinetic. Kinetic friction is constant, and that is mu kinetic into mg, coefficient of kinetic friction into mg. In questions, you will be separately given what is mu kinetic, what is mu static, when you need to analyze that. If only mu is given, so you understand both static and kinetic is mu. Okay, in some questions it happens. Only mu is given, it's not mentioning whether this is static friction coefficient or kinetic friction coefficient. Then we consider both is mu only, static and kinetic. There is some difference actually. Generally, the coefficient of static friction is a bit more than the coefficient of than the coefficient of kinetic. Static is a bit more than the kinetic. Why so? Like you also have that feeling, like if you are trying to push a heavy box, so the force you need to apply initially to move it is greater than the force that is required to keep it moving. Once it start moving, then keeping up it moving is less, you can say require less force as compared to moving initially. Therefore we say the coefficient of static friction is more than the coefficient of kinetic friction generally. Okay, and here if I write the equation, I'll say F applied force minus my friction force is equal to mass into the acceleration. So F minus mu kmg is equals to mass into acceleration, and there I'll solve for acceleration or whatever else I have to find. So what happens? You are trying to move that block by applying a force. You are trying to move that block by applying a force in this direction. Let us take F. This friction force F initially was static. Till the force is static, my applied force was equal to the static friction force because acceleration was 0. So static friction force and my applied force is equal. So here you see, this is my applied force, this is my static friction force, both are equal, so it is rising like this. till which maximum static friction force, till this level. After that, the friction will become kinetic. Kinetic friction coefficient a bit less, and after that, the friction force is constant. The acceleration will keep on increasing. Getting it? So this is how the friction force varies basically. Okay, now coming to the questions. As shown in the figure, a block of mass 10 kg lying on a horizontal surface is pulled by a force F acting at an angle 30 degree. Okay, here this angle 30 degree with horizontal. Mu s is given. The block will just start to move for the value of F. Okay, just start to move. Just start to move means your applied force in that direction becomes equal to your friction force. Okay, just start to move, both equal. Now in such particular cases, now what happens generally, I am talking about generally, students by default they consider that a normal reaction is equals to oh sorry, I did a mistake. Okay, yeah, so generally students what they think is this normal reaction is always equals to mg. Okay, I wrote mg only here. This is mu into n. This is mu into n. Yeah. Now normal reaction is mg in this case. Normal reaction is mg in this case, but not always. You may also write here also mg n as of now. N. Okay. Not always. The normal reaction may not be equal to mg if the force is at a particular angle. If the force is horizontal, then we can say normal is, I can say mg, but some conditions can change. Here also I am saying my static is less than mu n. Okay. Here n was coming equal to mg, therefore it was less than mu static into mg. But don't take normal reaction always by default as mg. In this particular case, normal reaction is not equal to mg. If you apply, you will commit a mistake here. You take the component of force F cos 30, F sin 30. Okay, and what other forces? mg, upward, normal. In the vertical direction, the acceleration is 0. So F sin 30, the upward direction plus normal in the upward direction, this is equals to my mg in the downward direction. So I will say normal comes out to be mg minus F sin 30. Okay. Now in the horizontal direction, if I talk about, one friction force will be there, and for just starting moving, I will say F cos theta is equals to my maximum value of the static friction force. Okay, the maximum value of this friction force. What is the maximum value? Mu into n, mu static into n. This is my F cos theta. Okay, so what is n? N I wrote there. So from there I can write F. So F is equals to mu static into n is mg minus F sin 30 and divided by, okay, this was my F cos 30. Getting it? Okay, so from here I have to find F. From here I have to find F. So this is one equation. I'll put the values. I'll put the value of mg. I'll put the value of mu static. I'll put the value of cos 30, that is root 3 by 2. Sin 30, that is 1 by 2. And from there we'll get F from this particular equation. Now you can put it, solve it, and let me know in the comment section what is the answer of this question. Okay, make sure you comment if you are solving it. Okay, moving further ahead, another question we are having. A block of mass 40 kg slides over a surface when a mass of 4 kg is suspended through an inextensible massless string passing over frictionless pulley as shown below. The coefficient of kinetic friction between the surface and the block is 0.02. The acceleration of the block is, okay, So kinetic friction coefficient is given, and what acceleration we have to find of the block. And if we see the options, the acceleration is non-zero, so we are sure from there itself that this block is moving and the friction is kinetic only here. Also in the question he is giving just the kinetic friction coefficient, so by default we can take it like it is moving, the friction is kinetic in nature. This tension force T, this tension force T, this is mg, it is moving down with an acceleration a, it will be moving in this direction with an acceleration a. Here my friction force is there and friction force is kinetic, so I'll say that friction kinetic is mu k into n. What is mu k? Mu k is 0.02 into what is n, and here this, because n is mg, there is no other force in the vertical direction, so that is 400. So this will become 8 Newton. Okay. So from here I have to find what is the acceleration. How to find that? You can write the equations for both the blocks. So for this block, if I say, I'll say t minus 8 is equals to 40a, and for this block if I say, I'll say mg minus t. What is mg? 40. Okay, what is mg? Mg is 40, so 40 minus t is equal to 4a. So t you can put in the above equation. So 40 minus a is my t, 40 minus 4a, minus 4a minus 8 is equals to 40a. So this is 32 by 44, is 32 by 44, and that comes out to be 8 by 11. 8 by 11 meter per second square. D option. Okay. That way also you have written that total pulling force will be mg minus friction force, and that is divided by total mass, that is 40 plus 4. That way also you will get this 8 by 11 as the correct answer. Now moving further, another question. A block of mass 5 kg is placed on a rough inclined surface as shown. F1 is the force required to just move the block up the inclined plane, and F2 is required to just prevent the block from sliding down. You may say, sir, what is the difference? In both the cases, the block is at rest. Okay, we have to find F1 minus F2 value. Now, just moving up means it has a tendency to move up. The friction force will be in the downward direction along the plane in the downward direction. Okay, and just preventing it from sliding, friction will try to oppose the sliding, and we are just giving a minimum force to prevent it. Friction will be upward, so the direction of friction force is changing in these particular cases. Okay, so let us write it here. So I am writing F1 and F2. So first of all, let us write F1 in this direction. Okay, just moving it up. For just moving it up, the two forces, one is my mg sin theta in this direction, another is the friction force will also be in the downward direction because it has a tendency to move up, so friction force will be in the downward direction, that is mu n. What is n? N is mg cos theta, normal reaction. Okay, so this F will be equal to the sum of these. Just moving means acceleration is 0, so mg sin 30 plus mg mu mg cos 30. Now F2 means you are just preventing it. When you are just preventing it, now I am writing F2. So when you are just preventing it from sliding down, your friction will be upward direction only, because if you leave a block, let us take on the inclined plane, in which direction the friction will be? Upward. okay, and you are applying a minimum force to hold it. So this friction is in the downward direction, which is mu mg cos 30. Mg sin 30 will be in the downward only, mg sin 30. So what is my F2 now? So F2 plus mu mg cos 30 is equals to mg sin 30, acceleration is 0. So F2 comes out to be mu mg, mg sin 30 minus mu mg cos 30. We need to find the difference between the two magnitudes. So you subtract these two. So what will happen? It will be 2 mu mg cos 30. Okay. So delta F is 2 mu mg cos 30. Okay. What is mu, by the way? Is it mentioned? Yes, 0.1. Put the values. 2 into 0.1 means 1 by 10 into mg is 50. Cos 30 means root 3 by 2. So this becomes 5 root 3, option B. So just preventing from slide means friction will be in the upward direction. Just move up means friction will be in the downward direction. Another question on friction. A block of mass 10 kg starts sliding on a surface with an initial velocity of 9.8. The coefficient of friction between the surface and the block is 0.5. The distance covered by the block before coming to rest. Now, initial velocity is given. Block is sliding now. Which force is acting? Only friction force. What is the acceleration? So friction force is acting, and that is kinetic, that is mu mg. So acceleration will be divided by mass, which is mu g. That comes out to be 0.5 and 9.8. So this is 9.8 by 2. Okay, this is my acceleration. So I need to find how much distance it will cover before coming to rest. So v square minus u square. Acceleration is constant, isn't it? So v square minus u square is equals to 2s. So what is v? V is 0, finally coming to rest, minus u square. What is u? 9.8 square is equals to, this acceleration is negative, by the way. So negative sign will come because it's just opposite to the velocity. So minus 2 into 9.8 by 2 into the distance. So this 2 got cancelled, this 9.8 got cancelled. So the distance it covered is before coming to rest is 9.8 meter. Option B. Okay. Just coming before coming to rest, it will cover a total distance that is 9.8 meters. Now, contact force and angle of friction. So what is contact force? Contact force basically is resultant of resultant force from the contact surface. Okay, what is the resultant of the two? Resultant of normal force and the friction force. These two forces, like a block was there, it is having a friction force like this, it is having a normal like this. Okay, and the resultant of these two becomes my contact force. That will let me choose another color. That will come somewhat like this. Okay, this we say as my contact force, or sometimes we say as reaction from the surface. So the resultant of friction and the resultant of the normal. Now angle of friction. So angle between the normal and the this contact force. Here just the contact force, not maximum. So the angle of friction is the angle between my normal and the resultant of this. This we say as the angle of friction, or a maximum contact force means, when we say maximum contact force, that means if the friction is static, we will consider the maximum value of that. For that, the maximum value of contact force will come, and this particular angle, let us take this angle is theta. So we say that the angle between the normal reaction force and the maximum contact force, this becomes my angle of friction, that is theta. Okay. Next is angle of repose. What is this? Now let us take, you are having a block placed on a surface. Now slowly I'm increasing the angle. At one particular angle, this block will start sliding, because initially it will not slide. At horizontal it will not slide. Up to some angle also it will not slide. After some angle it will start sliding. So the angle of repose is defined as the minimum angle, okay, of an inclined plane, which causes, let us take this angle, causes the object to slide down. Getting it? So this angle we say as the angle of my repose, and this angle is equal to the angle of friction. Okay, this angle is equal to the angle of friction. Can you find that? Can you find that at what angle this block will start sliding? Let us take kinetic friction. The static friction coefficient is mu static. So here we'll say that one force is mg, downward direction. Component of this is mg sin theta in this direction. This component mg cos theta. Friction force is in this direction, which will be mu. I'm considering the maximum because it just starts sliding. So mu static into mg cos theta. So just sliding means equate the two. So mg sin theta is equals to mu static into mg cos theta. Getting it? Mg will get cancelled and we'll get tan theta is equals to mu static. So we got my angle of repose. And if you talk about angle of friction in this, so friction force, I need to consider the maximum. What is that? This is mu mg cos of this particular, this angle of friction I'm finding. Okay, so this is mu into n is my mg in this case. Okay, so this theta, if I write tan theta, so this tan theta is equals to f, that is mu mg, divided by n, that is mg. So this comes out to be mu. It's the same thing. So we are getting the angle of repose to be same as the angle of friction. Okay, now the case of block over block. Let us take two blocks are kept like this. Now in these type of questions in mains, there is only one variety they are asking. What is the maximum possible value of force that can be applied such that these two blocks will move together? What is the maximum value of acceleration such that these two blocks will move together? There is no other variety in mains they are asking. They are asking only this variety. Okay, so some force is applied, F. Let us take this as m1, this is m2. Here this surface is having coefficient mu, and considering this to be smooth. Now if you are applying F, so what will happen? There is friction between m1 and m2, so that friction will try to move these blocks together, but at a certain point when this F exceeds a particular value, what will happen? If you make this F high, so what will happen? There will be kinetic friction between m1 and m2. m1 will not be able to achieve that much acceleration because friction force is limited. Static friction force will be there, it can reach up to a certain value, after that it will be kinetic. Okay, it cannot go increase as F will keep on increasing. Okay, so if you keep on increasing F, what will happen? After some time the friction will become kinetic and these two blocks will not be moving together. So what is that maximum acceleration? What is that maximum acceleration? Let us try to find out what is that maximum force that we can apply. Now for blocks to move together, together means this whole system is moving with a common acceleration a, and I'll say this a will come out to be F divided by m1 plus m2. This friction force will be sufficient enough to provide this much acceleration. What is the friction force on m1? This is m1, force m1g, normal reaction, that is m1g. It will have friction force in which direction? Forward direction, okay, because it is this friction force is trying to move it together. So the friction force in this is in this direction f. On m2 it is in the backward direction, but on m1 it is in the forward direction. So when I'll say f for m1, f is equals to mass into the acceleration. It is moving with an acceleration a, so f is equals to mass into the acceleration a. Okay, and we know that f max is equals to mu mg. Okay, is this clear? So f maximum is equals to mu mg, and this is my ma. So here I'll say my a max. So the maximum acceleration can be for this particular case is mu g. Put it there, a max. So f max will be a max into m1 plus m2. What it will become? Mu g m1 plus m2. Don't memorize this, try to understand concept, because things can change. It may apply force f1 on m1, then friction force will be acting on m2. It may also happen. Okay, isn't it? Yes, the force can be on m1 also, some force, and the in let us take two forces are given. What if two forces are given and then some conditions will be there? But we will not go into that much deep in this case, because in mains there is no varieties in this question. Therefore we need not go into that much deep. Just understand what is the condition to move together. So here we got that the maximum acceleration can be mu g, and the maximum force we can write like this. Coming to some questions asked in mains. A coefficient of static friction between the blocks is 0.5. The table is smooth. The maximum horizontal force that can be applied over the blocks to move the blocks together is, how much is the maximum? Same question. I'll say a maximum is mu into g, 0.5 into 10, that is 5. So f max is equals to a max into the total mass m1 plus m2. And what is this? 5 into 2 plus 1, 3. So this is 15 Newton. This is 15 Newton. Okay. Conditions can change. Don't remember the formula I'm saying. Just understand the concept. If force can be in 1 kg, then the things will change. How it will change, let me explain. Okay. So if on 1 kg, if I talk about, let us take the condition is like this. Force is here. This is 1 kg. This is 2 kg. Now, if you analyze 2 kg, only friction forces in the horizontal direction, then you need to find the maximum acceleration according to 2 kg. So on 2 kg, how much will be the maximum friction force? That will be mu into n. What is normal reaction there? Normal reaction will be 1 into g only, n. Okay, there it will be just the opposite. So mu, what is mu there? Mu is 0.5, so this is 5. So here maximum force is 5. So a max in that particular case will be my force divided by here the mass of this 2.5. So in that particular case a max will be 2.5. Here a max was 5. Getting it? So therefore I'm saying try to understand the concept. Don't just try to memorize the formula or things which I'm driving here. Another question, the block given in the given arrangement of a doubly inclined plane, two blocks of masses m and small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown. The coefficient of friction between the surface of the plane and the block is 0.5. The value of m, for which at 10 kg will move downward with an acceleration of 2 meter per second square. So it is having a downward acceleration of 2 meter per second square. It is having an upward acceleration of 2 meter per second square. it will be having some friction force in the opposite direction. F, what is that? Mu into N. Mu is same, yeah. So mu into mg cos 37, mu into N, okay? Cos 37. Cos, not 37, 53. This is cos 53. It will be having a downward force, that is mg sin 53. For this block, if I talk about, and also one tension force is also there on this. And for this block, one tension force is in this direction. This force mg sin 37. This force, friction force mu mg cos 37. If it is moving with 2, it is also moving with 2 acceleration. Now here just see what is the total pulling force divided by total mass. That way you can do. What is the total pulling force here? This mg sin 37 minus mu mg cos 53 minus mg sin 30 minus mu mg cos 37. These two are pulling it back. Okay, that is the total pulling force divided by my total mass, that is m plus m. Okay, divided by my total mass, and from there you'll get the acceleration. Getting it? Or you want me to write the equation? I can write the equation also. Like you can write separately the equations for both. For 2 kg, if I, let us say for this capital M, not 2 kg, this capital M is 10 kg, yeah. For this capital M, if I write the equation, what I'll say mg sin 37, mg sin 53 minus t minus mu mg cos 53. This is equals to m into a. And for that, if I write the equation, that is t minus mg sin 37 minus mu mg cos 37. This is small m into a. From this equation, I'll put t there and I'll solve for this. So these are the two equations, and then I can solve it. So you try to solve this equation and make sure you put your answer in the comments. Okay. Just put the values because here everything is given. Mu is 0.5, 1037 is 3 by 4, so cos 37 sin 37 you can find. Small m is given to us as 10 kg, capital M is 10 kg, small m we need to find. Acceleration is given as 2 meter per second square, yeah. Acceleration is given, you need to find small m, from there you can find that. Now we are coming to dynamics of circular motion. So basic understanding of circular motion, we have already discussed that in the previous videos. Okay, there we discussed circular motion, what is angular velocity, what is angular acceleration, what is centripetal acceleration, what is tangential acceleration, what is the total acceleration there, what is the uniform circular motion. All these things we have discussed. But let me quickly revise this. Angular velocity we wrote as omega, that was our d theta by dt. Then we discussed angular acceleration, that is d omega by dt. Okay, then my centripetal acceleration, that is v square by r. This centripetal acceleration was responsible to change the direction. The tangential acceleration, a tangential, that is r alpha, and this is responsible to change the magnitude of the velocity. This is responsible for direction, this is responsible for magnitude, and if we find the total acceleration, that is a resultant of centripetal square plus tangential square. These things we have discussed. Now let us take a rope is there, a particle of mass m is attached with this rope, and it is moving in a circle with a uniform angular velocity omega. Let us take, and I ask you, what is the tension in the string? Can you tell me? Can you write the equation here to find the tension force? Take a minute, think, and then come back. Okay, I hope you are back. So here if you see this mass m, is having one force T there. It is moving in a circle, so its acceleration is there in this direction, is centripetal. What is that? That is my V square by R, or I can say omega square by R, omega square R, okay, not by, okay. So I can say here tension force is equals to my mass into centripetal acceleration. Simple. This is mass into V square by R, or this is mass into omega square R. Now it may be having some tangential acceleration. Accordingly, you can write the equations if that is there. Okay. And you can take an example. Let us take particle is moving in a vertical circle, maybe like it. Okay. Like this, it is moving in a vertical circle. So here I need to find what is the tension. So then what we need to write. So then you see what are the forces here. One force is mg. Okay. Another thing is the tension force in the upward direction. Okay. Let us take it is moving with the velocity v here. So we will say that T minus mg, T minus mg is equals to my mv square by r. So here I'll get T is equals to mg plus mv square by r. Okay. Now horizontal circular motion, as we discussed, let us take particle is moving or may not be connected with the center. Let us take it is moving in this horizontal circular motion. So it is moving here. We know, let us take velocity v. So I'll say it will have one force here in this direction f, that is my mass into centripetal acceleration. Who will provide this force? It may be friction, or it may be some other external force which is providing it, maybe anything. So I'll say this is my mass into centripetal acceleration. Another force can be along the velocity, okay, which is trying to increase the magnitude of velocity or decrease the magnitude of the velocity. Okay, if another force is there, and here also let us take some acceleration is there, A tangential. So I'll say I'm considering this force to be my f dash. So my f dash will become mass into tangential acceleration. This is my f and this is my f. F is towards the center, which is providing the centripetal acceleration, and this f dash is towards the tangent, which is providing my tangential acceleration. These two are perpendicular directions, okay, independent. Okay, so separately you can write the equation f is equals to ma along both the directions. Okay, now coming to canonical pendulum. So here a particle is there which is attached to a string and it is moving like this in a canonical form like this. Okay, now here we need to find, let us take tension and a theta and all those things we need to relate. How to do that? This radius is r, this tension force, let me write here, this tension force is T, with the vertical the angle is theta, so this angle will also be theta. Another force is force due to gravity in the downward direction, this is mg, and it is moving in a circle like this. Now in the vertical direction, if we see, there is no acceleration in the vertical direction, so I'll say my T cos theta is equals to mg. In the horizontal direction, it is having an acceleration in the horizontal direction, so I'll say T sin theta is my mass into, what is that acceleration? Centripetal acceleration. And what is that? Omega square r, or v square by r, anything. R we are using small r. Okay, now you can divide these, you will get tan theta is equals to omega square r by g, or v square by rg, same thing. You got tan theta, you can find tension and other things also if you need to find here. So nothing special, just the same regular thing. Now the death well. So you might have seen the bikers moving their bike in a death well. So what happens there? You may say, sir, the surface is like this. How still they are able to remain in contact? Okay. So what happens is, let us take the bike is somewhat here. Okay. Downward force is mg. Now here they are having a centripetal acceleration that is in this direction, and that centripetal acceleration is provided by the normal reaction. So I will say here normal reaction is not 0. So normal reaction is mv square by r. If this velocity is 0, then the normal reaction will be 0. At rest he cannot be at that particular position, but he is moving with some velocity. So this normal reaction is providing that centripetal force. Therefore the friction force will also be non-zero, because friction force, I'll say, that is F max if I say, or F is less than equals to mu n. So F max is basically my mu into n. So friction force is non-zero in this case. Getting it? Friction force is non-zero in this case. And if friction force is there in the upward direction, mg in the downward direction, friction is balancing. Friction is balancing this. Therefore, this is how they are able to move in this particular motion, even though it's like a well shaped. Let us discuss this question. A car is moving with a constant speed of 20 meter per second in a circular horizontal track of radius 40 meter. A bob is suspended from the roof of the car by massless string. The angle made by the string would be, with the vertical will be. Okay, so bob is there like this with a vertical making some angle theta. Now car is moving in circle, means the bob is also moving in circle. Let us take the circle is like this. This force is tension force. This is my mg. With the vertical I am considering this angle as theta. So this is t cos theta. This is t sin theta. Okay, it is having an acceleration in this direction. That is my centripetal acceleration. So in the horizontal direction, vertical direction will write the force and acceleration. In the vertical direction, t cos theta is mg. And in the horizontal direction, if I say t sin theta is m into centripetal acceleration, what is that? V, the speed is given there. Okay, so I'll write in terms of speed. So v square by r. Divide these two. So you'll get tan theta is equals to v square by rg. Now you put the values. What is v? 20. So 20 into 20 divided by what is r? Radius is 40. G is 10. So this becomes 1. So tan theta is 1, means theta is equals to 45 degree pi by 4. C option. Okay. Now another question on circular motion, horizontal circular motion. One end of a massless spring of spring constant K and natural length L0 is fixed, while the other end is connected to a small object of mass m lying on frictionless table. The spring remains horizontal on the table. If the object is made to rotate in a angular velocity omega about an axis passing through the fixed end, the elongation of the spring will be. Okay. Let us take spring got elongated by some distance x, and this length will become what? Initial was L0, so this will become L0 plus x. It is moving in this circle like this. Okay, so here I'll say my spring force is providing my centripetal acceleration. So spring force is K, L0 plus x is equals to m. This is kx, not L0 plus x. kx, elongation only x. So kx, this is my spring force. I did a mistake. Okay, this is only spring force. So spring force is equals to mass into centripetal acceleration. So m into omega square into r, which is L naught plus x. From here, I had to find x. So x into k minus m omega square is equals to m omega square L naught. So x comes out to be m omega square L naught divided by k minus m omega square. Yeah, C option. Simple concept. This question was asked in 2022 JEE Mains. Now, circular turning on a road. Now, let us say car is moving and there is a circular turn. The car has to take a circular turn. So, what happens? So, sometimes you have seen like bikes skidding while taking a turn. The speed was very high. The driver could not control and the bike skid. So, what was the reason the bike was skid there? The reason is there the centripetal force that was needed was not sufficiently provided there. Okay, it means in simple words, if I say, who is providing the centripetal force? Friction. So friction was not sufficient to provide that centripetal acceleration. Friction was less, so therefore the bike skid or the car skid. So what happens when it is moving in circular motion here? It is moving in circular motion. It is having a centripetal acceleration like this, and that centripetal acceleration will be provided by what? Friction force. So I'll say that my friction force is equals to mass into centripetal acceleration. What type of friction is this? Static, because in this direction the motion is not there, in this direction, so the friction in that is static. So this static friction force has a maximum limit, that is mu into n, mu static into n. Okay, so I'll say F static maximum, or let me write here, F static is less than mu into n, and this is my mass into centripetal acceleration v square by r. This is less than equals to mu static, n is mg, m got cancelled, so v has a upper limit, mu static root rg. It has a upper limit of mu static into rg, root of mu rg, that is the upper limit. If you increase the speed greater than this, what will happen? It will skid. The driver will not be able to control the car. Therefore, while taking a turn, it's better to decrease the speed because the friction may not be sufficient. Okay, is there any other way? Can we increase the normal? Generally not. We cannot increase the normal, but yes, if you talk about some of the cars, they are designed in such a way that when they move, they provide a negative lift, due to which the normal force is sufficiently increased and they can take a sharp turn. Okay, so the shape of the car is designed like that. Because of the velocity difference, you can say, of the air above the car and below the car, a negative lift is generated, due to which the normal becomes very high. If the normal becomes very high, although the coefficient of static friction is less, friction force becomes, you can say, sufficient to provide that acceleration. Okay, let us discuss this. A car is moving on a horizontal curved road with a radius of 50 meters. The approximate maximum speed of car will be if friction coefficient between the tires is 0.34. So maximum we have to find. We'll say V max is equals to root of mu rg. What is mu? 0.34. What is r? 50, and g is 10. Put the values, solve it. Don't forget to comment the answer. Okay. I need to see how many students are coming till here, solving questions with me actually. So make sure while solving these questions, you keep commenting your answers. So I need to know like how many students are completely watching this video. A modern Grand Prix racing car of mass m is traveling on a flat track in a circular arc of radius r with speed v. If the coefficient of static friction between the tires and the track is mu static, then the magnitude of negative lift Fl acting downward on the car is, now yes, this is the negative lift I was talking about. So this car, these are, you can say, designed car, designed in such a way that you can take very sharp turn with higher velocity also. Not with normal car you cannot do that, but these cars are designed like that. So if you see like cars like Ferrari and Bugatti and like that, they have their structure like that. So when they move, there is a pressure difference that is created by the air of the air velocity above the car, below the car, due to which a negative lift is generated. So negative lift, he is talking about how much is the negative lift. This car is moving, okay, let us take here, it is having a centripetal acceleration in this direction, E centripetal. So I will say that my force, friction force, that is equals to mass into centripetal acceleration. Okay, and what is this friction force? Friction force is mu into n. What is n? N will have two components, one due to mg, another due to negative lift. So I'll say mg plus this negative lift, let us take FL. I'll put it there, okay, equate the two. So from there we need to find FL. So what it will become, FL will be mv square v square by mu into r minus mg. This is what we are getting. I think option A is correct. Yeah, got it. Getting it? So there one component due to gravity will be there for a normal, okay, like 1 mg is there plus another negative lift is there, and total normal is sum of the two. This is my car, one force mg, another force negative lift, and in upward direction my normal is there. So I'll say normal is sum of these two. Normal is sum of those two. Okay. Now circular turning on a smooth banked rod. Now let us take a banked rod is there and that is smooth. This is the banked rod inclined at some angle with the horizontal theta. The vehicle is moving like this towards us. It's a circular kind of, it is moving like this. Okay, let me draw properly. Try to take the help of the shapes. So I can take, this is how in the circle it is moving. Okay, now there it is smooth, there is no friction, still it can move like this. Showing the forces, what all forces are there. One is force due to mg, force due to gravity mg. Okay, taking the component of mg, so I'll say this component is mg sine theta. No, I'll not take the component because the acceleration is in this direction, centripetal acceleration. So need not take the components. So this is mg and another is the normal reaction here, normal force n perpendicular to this. And I'll take the component of n. Let me draw this dotted line with the vertical. So if I ask you how much is this angle, this was theta, this is theta, 90 minus theta, so this angle is theta. You see, this angle is theta, this is 90 minus theta, so this angle will become theta. So n cos theta will become my mg because there is no acceleration in this direction, vertical. So n cos theta is equals to my mg, and n sin theta will be mass into centripetal acceleration because that will be providing the centripetal acceleration. So n sin theta is equals to mass into the centripetal acceleration, which is v square by r. Now divide it. So tan theta is becoming v square by rg. Okay. So if the bank road is smooth, so with this velocity if it will move, friction is not required at all. But any velocity other than this, what will happen? It will skid either in the upward or in the downward direction. We have a question on this. A train is moving with a speed of 12 meter per second on rails which are 1.5 meter apart. To negotiate a curve radius 440 meter, the height by which the outer rail has to be raised with respect to inner rail is. Okay, now try to understand this. What is happening here? Now, friction is not there. You are adjusting the outer rails and the inner rail. Okay, so you are tilting the track actually like this. You are tilting the track like this. By tilting the track, let us take this height as h. Okay, and what was the height? Yeah, 1.5 meter apart. They are 1.5 meter apart. So this was given to us as 1.5 meter. And now the height of the outer is raised. Okay, outer is raised. What that height should be, he is asking. Now it is moving in a circular track like this. Friction is not there. We need an angle elevation, and that is attained by this theta. So I'll say that tan theta is equals to v square by rg. Simple. And what is tan theta here? H by 1.5. So what is h? 1.5 into v square by rg. What is v here? V is 12 meter per second. So 12 square. What is r here? R is 400. What is g here? G is 10. Put the values, solve it. Make sure you comment your answer. Okay, because when you solve the questions, actually these formulas will go into your mind. You understand the concepts very nicely. You will be quickly be able to apply this formula whenever required again. Now circular turning on a rough banked road. Now we are taking a condition when the friction is there. Okay, banked road is there, but in this case my friction is there. So this is, let us take here my vehicle moving like this in a circular track, having a centripetal acceleration in this direction, mg in this direction, normal in this direction, and what else? Friction force. Now friction force can be in the downward direction, can be in the upward direction, depending upon whether you are trying to get the maximum velocity or the minimum velocity. And friction force can be zero. Friction force can be zero when v is equals to when tan theta is equals to v square by rg. In that particular condition, my friction force will be zero also. Okay, so what I am doing is, here a limit will exist, a range, maximum to minimum range will exist. Your velocity should be maximum this, minimum this. Okay, let us try to find the maximum velocity. When you are talking about maximum velocity, it will have a tendency to skid upward, outward. When it will have a tendency to skid outward, friction will be acting in this direction. Okay, friction will be acting in this direction, and in this case, if I say this angle is theta, vertical, there is no acceleration, total force 0, so n cos theta is mg. Okay, oh, not mg, n cos theta is mg plus this angle is 90 minus theta, so f sin theta will come, mg plus f sin theta. So for Vmax, my f is equals to mu into n. Friction max we have to take. Okay, we have to take the friction max. Therefore, f is equals to mu into n. So put f is equals to mu into n here. Okay, so if I write it, n cos theta is equals to mg plus mu n sin theta. So from here I can take the whole n term on this side. So mg will become n into cos theta minus mu sin theta. Getting it? This was in the vertical direction. Now in the horizontal direction, if I talk about, one component of n, that will be n sin theta. So n sin theta. Another component of f, what that will be? F cos theta. So plus f cos theta, and that is equals to mass into centripetal acceleration. Okay. Now you can again put f as mu n. So n sin theta plus mu cos theta is equals to mv square by r. This is equation 1. This is equation 2. Let us divide these two equations. When you divide these two equations, how should we divide? First, I'll take second equation, then I'll divide with the first equation. So it will become sin theta plus mu cos theta divided by that is cos theta minus mu sin theta, and this is equals to v square by rg, and this is my maximum velocity. So from here I can say v max comes out to be root of what? I'll divide this with cos theta also, so tan theta plus mu divided by 1 minus mu tan theta. Okay, so rg tan theta plus mu divided by 1 minus mu tan theta. This is my V max. If I talk about V min, then what will happen? Direction of friction force, you need to take the opposite. Okay, direction of friction force, you need to take the opposite. Direction of friction force means if it is here in the downward, so with minimum velocity it will have a tendency to move in downward direction, so friction will come in the upward direction. So here it will be minus, here it will be minus, so here it will be a minus, here it will become a minus minus plus. So if we talk about V min, so this will become root of rg a tan theta minus mu divided by 1 plus mu tan theta. Okay, and if you are having velocity as v tan theta is equals to v square by rg, if that condition is coming, then friction will be 0 in this particular case, because we have discussed that if road is banked, that condition is there, friction is 0. Okay, so we are having this another question. The normal reaction n for a vehicle of 800 kg mass negotiating a turn of 30-degree banked road at maximum possible speed without skidding is. So what is the normal reaction? The condition is maximum possible velocity without skidding, and we need to find maximum velocity is maximum. It means what? Maximum velocity is there, it means friction will be in the downward direction f. This will be my normal reaction n. This is my mg. In the vertical direction, if I apply equilibrium, so I'll say my n cos theta is equals to f sin theta plus mg. Velocity is maximum, f is mu n. So this is mu into n into sin theta plus mg. This is n cos theta. So from here n comes out to be mg divided by cos theta minus mu sin theta. Okay, and just you can put the values and you can solve it. Your theta is 30 degree, mu is 0.2, okay, cos 30 is given as 0.87, so you can solve it. Make sure you comment the answer. Okay, so this is all about this chapter. We have considered all the types of questions that are asked, different varieties. We have covered each key concept in detail. I hope you are able to understand all these things. Make sure you put your thoughts in the comment. Okay, so which all things you liked about this video, and make sure the answers also. And after that, what is required is you need to practice the questions yourself. So in the description box you have the link of our app. Click on that, you'll go to our app. There in our batch you'll get the notes of this video as well as the practice sheets. So these are hand-picked set of questions. So make sure you solve all of them. Thank you all the best.